one aircraft transformed the world.
Request permission to carry out a high-power ground run.
With 2 decks, carrying over 500 passengers. And wings the width of a football pitch. It was twice the size of any airliner before. The Boeing 747. Affectionately known as the Jumbo Jet.
Okay, going up on 1 and 4.
It's still an engineering marvel.
It's just awesome, the power of these things.
Now, as one 747, Victor X-Ray, is stripped to its bare bones and given the biggest overhaul of its life, there's a rare opportunity to explore deep inside its hidden features.
Wow, this is pretty cramped. That is massive.
A 200-strong team of highly skilled engineers take on the challenge of checking over 20,000 parts of this mighty aircraft.
If we don't take that out now, that crack will just run and run and run.
Safety is paramount in this finely balanced machine. Every component, from its engines to its kettles, must be intricately examined for damage.
The amount of knowledge and experience we need to learn is just incredible.
I've got 3 children, they're very proud that Mummy works on airplanes.
Well, when you see it barreling down the runway as well, 140, 150 knots, you think, I did them bolts up.
And we'll reveal what happens to a Jumbo when it reaches the end of its working life. This is Engineering Giants.
I'm Rob Bell. I'm a mechanical engineer, and I've always loved to get my hands on complex machines to discover how they work.
I'm Tom Wigglesworth, an electrical engineer with a passion for big machines. And this is Victor X-Ray, the 747 that's about to let us in to all its engineering secrets. This is the shortest flight this plane will no doubt ever do. It's flying just 132 miles, from Heathrow to Cardiff Airport.
And in a few moments' time, this is where the 747 will arrive. This enormous maintenance hangar. All planes are regularly maintained, but every 6 years, 747s come here for a complete overhaul. That means that they're stripped right down. Every part is meticulously checked before being reassembled and sent back out into service.
This is the first time that British Airways have allowed cameras to film the complete overhaul of one of their aircraft. And we'll be there for every critical stage in the engineering process.
This is a perfect opportunity for me and Rob to see deep within the Boeing 747 and appreciate how amazing these enormous machines are. So there's your aircraft coming now.
Victor X-Ray was the 1,172nd Jumbo to be manufactured by Boeing. It was delivered to the airline 14 years ago and has since flown 36 million miles, equivalent to 1,500 times around the world.
So we have the shutdown checks, please.
As Captain Doug Brown shuts down the engines and hands the plane over to the Cardiff engineering team, I've been offered a rare glimpse inside the flight deck. Hey Doug, thank you for letting me in here. This is
No problem.
Well, it's every boy's dream, isn't it?
Absolutely.
Every boy's dream. What is the least used or pressed switch?
To be honest, very few of them get used in flight. When the 747-400 was designed in 1989, it moved from being a 3-crew aeroplane with a flight engineer's panel there, which had thousands of buttons, dials and gauges, and a full-time flight engineer, to an automated 2-crew aeroplane with just 2 pilots.
So this is a simplified version?
This is, in some ways, yes, but what's going on behind the scenes is quite complex. The actual heart of the aeroplane is this flight management computer. And what that allows us to do is to program the aeroplane and the autopilot of the aircraft with a lot of the information before flight And then as we go through the flight, we're actually using the flight management computer to control the aircraft as much as anything else on the airplane.
In the case of raw flying, what's the minimum amount of controls you'd need?
In the absolute worst case, you can fly the aircraft using these three basic instruments here.
Okay.
Altimeter horizon, airspeed indicator and altimeter.
Okay.
I don't know of any case where a 747's got down to flying on those instruments. There is a huge amount of redundancy built into the airplane.
Now, it's time for the £200 million worth of 747 to be carefully towed into the maintenance hangar, where it will live for the next 5 weeks.
I always wondered what it'd be like to be part of the ground crew at Heathrow. I'm guessing I'm getting a bit of a feel for it now. Handbrake on, good to go.
Now I can finally climb aboard through what is currently the only way in, a maintenance hatch in the belly of the plane.
Welcome aboard, BA Flight 319.
Thank you very much. How's the flight?
Excellent, thank you.
Oh, cheers.
I'll give you a hand. Here we are. First class.
It's pretty spacious up here.
Very spacious. Been sat in C1A.
How's the view from up there?
I'll show you.
Oh, that's the stuff.
Absolutely, yeah. This is 1A.
Reserved for the creme de la creme.
Absolutely.
Which makes this seat what?
Mick Jagger's girlfriend.
That'll do.
Now that Victor X-Ray is safely inside the hangar, the engineering team can begin the monumental task of stripping the jumbo back to its aluminium shell and forensically examining all of its critical parts for the smallest defect.
Because number one to us is safety. Safety, safety, safety. We are looking after people's lives here.
You can't make any mistakes. You got to be right all the time. You know, there's no garages at 36,000 feet.
Over the next 5 weeks, engineers will work in teams within different areas of the plane, methodically searching for any signs of damage amongst Victor X-Ray's 6 million components.
One day we come into work and we'll be doing the cabin, which is very involved. There's all sorts of different disciplines of engineering that the cabin holds. And the next day we could be on the wing. The next day we could be doing the engine runs at the end of the check, which is pretty exciting.
This complex operation will take over 30,000 working hours, with the team having to complete 12,000 separate jobs.
We pretty much run 7 days, 24 hours.
General Manager Bill Kelly is in charge of the maintenance facility.
How many years would that be flying for?
Well, this aircraft could fly upwards of 25 years. You know?
Really?
So, yeah, absolutely. Very robust, very reliable, strong aircraft. And when well maintained, as we do, they'll go on for many, many years yet.
Bill and his team are under massive pressure to finish Victor X-Ray's overhaul on time. On the same day it's due for completion, the jumbo is scheduled to fly passengers to South America. Delays can cost millions of pounds.
You know, you get something wrong in maintenance where it delays you by a day or 2 days, it can really start to impact the rest of your operation. So you need to be on the ball, you know.
Much of the work on Victor X-Ray's fuselage needs to be carried out at height. The tip of its tail fin is 20 meters above the ground, so the aircraft will be surrounded by this rig, designed by these engineers specifically to fit a 747.
It's not until you get right up close to the tail fin, like I am here now, that you get a sheer sense of scale for the whole thing. From the tip to the ground is almost 70 foot. And looking back along to the front of the aircraft is a perspective I've never seen before. It's seriously impressive.
The first big engineering challenge is to test one of the plane's heftiest components, the 18-wheeled landing gear. Locked into the scaffolding rig, the plane can't be propped up like a car, so its 180-ton weight is supported on 3 jumbo-sized jacks as the floor is lowered.
So I can see clear ground now between the wheels and the floor.
A failure of the mechanical systems that lower the landing gear could be disastrous. So this is the only occasion when engineers have the opportunity to check that the wheels can drop safely if the pilot has to rely on gravity.
Whoa, jeez. And here they come.
The landing gear weighs as much as a double-decker bus, so if it was simply allowed to fall down, it could potentially cause serious damage.
Let's get the front one done.
So its mechanisms are designed to offer enough resistance to control the speed of deployment.
So now they've dropped. The guys are just giving them a push to get them finally locked into place. If you're in air and you had to do that, the pilot would just kind of swing the plane a bit and get them to swing out and lock. And for the back gears there, the air pressure that's flowing past it would lock those back into place. What are these two plates at the top here?
Well, on the nose wheel, you've got no brakes.
Okay.
So when the aircraft takes off, the wheels are spinning pretty fast. So those are basically big scuff plates. The tyres will hit them, and it just slows them down and stops them.
Okay, okay.
Inside Victor X-Ray, the cabin team are preparing to strip out all the seats. Melanie Gedders and Janice Nash are among a growing number of female engineers working at the facility.
You say you work for British Airways, everybody knows the label, the brand, and they assume that you're cabin crew, you know? And they don't naturally assume that you work in engineering. So it's something to be proud of. I've got 3 children, they're very proud that Mummy works on airplanes and fixes airplanes, so that's definitely one to tell the kids.
Brilliant.
Yeah, you go home from work one day and all your friends are saying about being stuck in the office, and then you go home and say, I've been walking the wing today, and they're like, wow, it's great.
Through rigorous training, engineers must learn every facet of the 747. Stan Williams first worked on the Jumbo 19 years ago, and flying on one has never been the same since.
I'm listening for everything.
You listen out.
You can't help it. I wish I didn't. Sometimes I'll put headphones on because you don't want to hear. There's lots of noises, different noises that go on an aircraft when it's in flight. And but you can't help it. It's in our blood, if you like.
Before everything disappears from the cabin,
This is the CSD's office.
cabin crew member Becky Wadsworth has agreed to reveal some aspects of working on a 747. She spent over 10,000 hours in the air on planes like Victor X-Ray, where space is extremely tight.
These are the ovens.
These are the ovens,
Yeah.
On an average flight, Becky and her team will serve 300 passengers over a ton of food and drinks. Is it true that when there's 2 pilots on board, they have to have a different meal?
That's absolutely. So, you know, should there be something wrong with the chicken, for example, then you don't want them both coming down ill with the same things.
And it's those little flashpoints that, I mean, who decides first?
It's normally the captain.
Captain first, co-pilot gets what's left.
Absolutely. I mean, the captain will often say, you choose first.
Oh, what a lovely English tradition. A 14-hour flight in cramped conditions is hard work.
Well, you would hope that they would discuss it.
So today's 747 crews are able to use a secret compartment above the passengers' heads.
At the stairs here is the crew rest area.
Space is of a premium, isn't it, up here?
Absolutely. Cosy.
Oh, wow. So what's the longest flight you do?
It's about sort of 14 hours from Singapore.
And in that time, then, how long would you get to spend enjoying this luxury?
You'd get about, sort of 3.5 hours rest.
So I think what you also should have is a little button to call a member of the public up to help.
Back down in the cabin, the next test is on a critical safety component that airlines hope their passengers will never see.
Go on. Whoa! That was impressive.
Failure of the chutes is not an option. With lives depending on them, they must inflate within seconds and stay inflated. So all 12 chutes are sent to the interiors workshop for rigorous testing.
Wow, it's huge.
Here, specially trained engineers like Michael Wake ensure that the slides are leak-free and inflate at incredibly high speeds.
Basically, they've got to open up within a certain time limit,
Okay.
which on these particular unit is 3 seconds.
Okay, so what's the process behind inflating one of these rafts?
The door open.
Yep.
And then the cylinder then charges 300 psi.
And that's this here?
Yeah.
There's a huge technical challenge with the inflation of such a large device. To inflate something the size of an aircraft life jacket, a small canister can provide enough air. But the same system would require a 3-metre-long canister on an escape chute. So instead, when triggered, the canister of compressed carbon dioxide and nitrogen delivers only an initial boost. The clever technique is that these gases are forced through a narrow gap, which causes them to accelerate rapidly. This acceleration creates a vacuum that then sucks in enough ambient air to inflate the entire slide in 3 seconds.
That was pretty quick.
Yep.
3 seconds, we happy with that?
Yep.
Wow. And look at it, I mean, it's
solid there.
Absolutely solid.
Testing the escape chute is the easy part. Now, like a parachute, the 30 square meters of material must be folded precisely back into its container, measuring just half a square meter.
And typically that'll take how long?
6 hours of hard labour.
Wow.
It's as much an art as science. It's all too easy to take flying for granted. As passengers, we're oblivious to the fact that the enormous metal tube we're travelling in is flying through the air at close to 600 miles an hour, and at a height similar to Everest, an atmosphere unable to support life. Engineer Gavin Beverstock is showing me how Victor X-ray pumps air from its engines into the cabin to create an atmospheric pressure similar to conditions on the ground.
Due to rise in altitude means a decrease in pressure, but also due to comfort for passengers, it has to be maintained, because obviously when we're on the ground we're at 14.7 psi, and as you're rising through the air, it reduces down, and once you get below 10 psi, it's not very comfortable. You can start having breathing problems, and it is so thin that you will struggle.
But the greater the pressure of air that these pipes pump into the cabin, the stronger the fuselage needs to be. That would add weight to the aircraft. So there's a compromise. Planes usually fly with a pressure equivalent to between 6,000 and 8,000 feet, comparable to the world's highest cities. That means reduced oxygen, and is one of the reasons we often feel tired on a flight. Pressurizing the cabin can also cause metal fatigue, because as air is pumped in and out of the aircraft, its fuselage expands and contracts.
You can see all the dimples along the skin of the plane, which when it's pressurized up in the air, all gets smoothed out.
It's a pretty amazing bit of engineering, but this frequent flexing of the fuselage can cause cracks. It's one of the major reasons why Victor X-ray is undergoing this intensive operation.
In order to thoroughly examine every inch of the airliner's internal shell, engineers have to remove almost every fixture and fitting inside the cabin. Some 747s can take over 500 passengers, but airlines can use tracks in the floor to choose their own seating plan. On Victor X-ray, Mick Gregg and his team must strip out 299 seats.
Mick, with the right Allen key, to just sort of steal yourself a bit of extra leg room in flight, would that... Yeah.
No, it wouldn't. Not unless you got a ham and a drift with you as well.
You'd never get past security, would you?
No, you wouldn't.
They are light. They're lighter than a settee, aren't they?
Yeah. There you go, Tom. Done.
Once removed, Victor X-ray seats are sent to the interiors workshop to be reupholstered and put through their paces by veteran seat tester Mark Jago.
So is it your job then to sit in this chair, watch a few films, play a few games, and then say, yeah, we're good?
Yes, it's a terrible job, but somebody's got to do it.
Back in the hangar, work continues in the cabin.
All these sidewalls are yet to come out. All the dados on the bottom are all to come out.
300 floor panels must be removed.
All the centre trough area there gets reworked.
180 window protectors and blinds taken out. and 140 sidewall panels stripped off.
This is the skeleton of the plane here. This is the, behind here, that's the framework. Aluminium frame?
Yeah, it's all aluminium. Won't have steel. Steel's too heavy. You want your aircraft to be as light as possible, don't you?
And that installation is pretty vital, isn't it? 'Cause it's sort of minus 50 degrees outside there.
Yes, it is. I believe it's about minus 56 degrees, around 30 to 35,000 feet.
And that's enough to protect you from that
Yeah.
minus 50 odd outside.
It's 2 days into the overhaul, and most of the first-class cabin fittings have been removed. The team can now begin the painstaking task of searching every inch of the internal frame for the smallest of defects.
And lo and behold, we found a little crack down in the corner, which we're going to put right, yeah. Your favourite seat, 1A?
1A is my favourite.
Shift manager Paul Thomas has discovered a minor crack in one of Victor X-Ray's floor supports.
Which is right in the corner. You can see the telltale, and it runs right to the corner. They normally emanate from fastener holes, so a rivet, and then run out.
Or sharp edges, you know. Or...
Yeah, well, you can see the line
Yeah,
when it's
yeah.
tracking. So, yeah, we pretty much got to replace that part now.
And you visually inspect the whole structure?
Absolutely. If we don't take that out now, that crack will just run and run and run and run and run. So we found it now. So the floorboards will come up. We'll de-rivet all this area.
Just for that, I mean, that...
Just for that small little crack.
Yeah.
Reassuring, yeah?
It is reassuring, but yeah, because I mean, my car is, you know, call that a crack. I'll show you cracks.
No laybys at 38,000 feet, I'm afraid.
There are no laybys in the sky. There are no laybys in the sky.
Absolutely.
Yeah.
It's day 4 of the overhaul, and work's beginning on Victor X-Ray's largest components, its wings.
Really, from wingtip to wingtip, we're looking at about 211 feet. So
How big is that?
a huge wingspan.
That's about a football pitch, then?
About a football pitch, yeah.
Overseeing the work on the aluminium and carbon fibre wings is shift manager Chris Morgan.
Obviously, they're very sturdy, but there's quite a bit of movement, isn't there, in the actual...
Yeah, so I mean, if you can see this movement here now, you get a total
Very
displacement up and down is about 32 feet. That's because you don't want a wing to be rigid. They need to allow for turbulence, they need to allow for airflow.
How air flows around a wing is crucial to achieving flight, and yet, incredibly, even among experts there are different theories to answer the question, how does a plane fly?
And most people have that question answered with Bernoulli's theory. And Bernoulli's theory suggests that air going over the top of the wing has to travel further than the air underneath. Because it's got to travel further, it speeds up. Because it speeds up, the air particles spread out and diffuse.
This results in lower pressure above the wing than the pressure beneath. That pressure difference literally pushes the plane into the air. But this doesn't explain why planes can fly with symmetrical wings. In fact, it's the angle of the wing and the amount of air it deflects down that matters. Because according to Newton's third law, the air force downwards results in an equal and opposite force upwards onto the underside of the wing. At the right speed and angle, this is enough to lift the plane into the air. In flight, Victor X-Ray's wings are subjected to enormous forces. Apprentice Lewis Robinson Hoare has been scouring the surface of this wing to find any damage that may have occurred.
We found some damage during inspections, which the damage is round there, where all that is pulled away from the structure below it.
OK, so the composite started to come apart.
Defect spotted, it can now be repaired. It turns out that Lewis's engineering passion runs in the blood.
3 generations of my family have worked so it's just run with the family, I suppose.
Yeah. And are they on shift with you sometimes?
No, my dad's on the opposite shift to me.
OK.
Which is OK. And my Bampy's retired now.
Yeah.
So, but he used to work in here as well.
Lewis's next job is on Victor X-Ray's flaps, vital components which increase the surface area of the wings, allowing aircraft to fly at slow speeds. The only way the crucial hydraulic and backup electrical control systems can be thoroughly checked is to remove the flaps. Lewis has to control this crane with absolute precision.
The crane has been set to 0.9 of a tonne, which is the exact weight of the flap they're removing. That's so when the last guy undoes the last bolt, the wing doesn't drop to the floor or fly to the ceiling.
Is she off? OK.
Slowly but surely, the flap is removed from the wing, with barely a millimetre of movement up or down.
Let it go. It's all yours now, all right?
Look at his face, he's loving it.
During flight, air passes over these flaps and wings at hundreds of miles an hour. That causes friction and the build-up of static electricity. To deal with that, there are small attachments, known as static wicks.
If you could see it, how would that static look coming off here? Does it just sort of fizzle out? What sort of...
Literally that. Visibility-wise, it's often very hard to see.
Yeah.
But you will still get sparking
really?
That will occur.
Slight sparking, right?
Yes. Sometimes in the high, electric storms and certainly in a lightning strike, we will get these like sacrificial. They will take a little bit of a battering.
On average, every aircraft is hit by lightning once a year. So how does a plane deal with this phenomenon? This laboratory at the University of Cardiff holds the answer, because this is one of the few places in the world where scientists, led by Phil Lykauer, have the technology to make lightning of their own.
It might sound bad doing these lightning tests to planes and things, but absolutely everything on an aircraft has to be certified against all the threats it could be posed to it.
The state-of-the-art laboratory tests new materials as aircraft manufacturers look to find lighter, more cost-effective alternatives to the aluminium currently used. So why do planes get hit by lightning?
The aeroplane, since it's actually in the sky, it's a huge metal object, it induces the lightning strikes itself, because it's the only thing there.
So how do planes survive? To find out, we're going to test this aluminium model, similar to our own 747.
Let's blow it.
OK.
You might have the best job in the world.
Sometimes I think so. There's a lot of paperwork too, though.
Now, it's my chance to play God.
Basically, when I say fire, it's very easy. Just press fire. And fire. So as you see, the model aeroplane survived.
It did. It looks perfectly intact.
Everything and everyone inside a plane's protected by the aluminium fuselage, which is a good conductor. It allows the electricity to take the path of least resistance, along the fuselage and out again.
What would the passenger feel?
They might hear a loud thump, but that's about it. They shouldn't feel anything at all.
A graphic experiment illustrates the dangers of using a non-conducting material, in this case, plastic.
Fire.
Which is why all new material combinations are so extensively tested. Back at the hangar, work to strip back the 747 continues. Today, engineers are about to reveal one of the parts of the plane that the public never sees. The nose cone, or radome as it's known, shields the aircraft's weather radar, which needs to be checked for corrosion.
And it works on the radar principle, which is like a complicated echo. It fires out radio waves in a very, very fine focus. It fires a beam out and then listens to that beam coming back, which will bounce off any clouds or anything that's up ahead. And that information is fired out at different angles to allow a huge range of sight, which is fed back to the flight deck so the pilot can take whatever action he needs to take.
Victor X-ray is now a week into its overhaul, and next, its most valuable components are about to be removed for closer examination.
It is a big moment indeed. They're actually taking the engine off the wing. These things cost about £8 million each. The last thing you want to have happen is it come crashing to the floor.
As experienced as he is, it's a nervous moment for team leader Scott Kroll.
Like, I started as an apprentice 10 years ago, and I've worked my way up to team leader. But I mean, even as a team leader now, the amount of knowledge and experience we need to learn is just incredible. And I think that's what keeps me going.
Generating over 60,000 pounds of thrust, an engine exerts enormous pressure on the mounts that hold them in place. It's crucial that engineers remove the engines so they can examine these fixtures for signs of wear.
The pylon is that big bracket, if you like, you can see, which connects the engine to the wing. The engine to the pylon itself has got 8 bolts.
8 bolts?
Yeah, so just 4 at the front and 4 at the back. And that's what the boys are undoing now. They're undoing the forward back.
The 8 bolts are crucial in holding the engine in place, so each one will be sent to a laboratory and tested for weaknesses.
It is, yeah.
These all get sent away now, NDT'd, but we'll have a new set going back on.
NDT'd, non-destructively tested.
Nice. Maybe X-rays.
Yeah.
Yeah. Ultrasound.
Ultrasound, of course,
maybe,
looking inside, yeah.
For the drop, the 7-ton engine is supported in a sling attached to the crane.
It's an impressive operation to make sure this is all rigged up perfectly well, so nothing can go wrong.
Yeah.
You'll just be pushing it. Is it? I mean, it's heavy to push, or once now it's suspended, it's quite free?
We're just supporting it. Obviously, we try not to. All the work is done by the crane. Yeah. All right, so we let that do it. OK, clear, come down.
It's all happening.
OK, down.
Scott and his team slowly lower the engine, making sure that all of its pipes are disconnected.
To be honest, it seems like the tension is being transferred from the crane into the engineers here. You can see them all getting more and more focused as it slackens off.
Going down again.
I don't think even steel toe caps would withstand the force of one of these coming down.
Looking pretty good. We're almost there. Yeah, it's in. It's in? Yeah, we're good. And that, ladies and gentlemen, is a wrap.
So at the end of the day, Scott, when you go home, you've still got that job satisfaction with you?
Oh, definitely. I mean, you know, every day I go home and I see my little girl and she says, Daddy, how did your day in work go today? And I say, honey, today Daddy fitted an engine. Not just any engine, an RB211.
Oh, here we go. Full-on impression now.
Yeah.
When turning, the big fan at the front sucks in air, which is then compressed, mixed with a mist of fuel, and ignited in a combustion chamber. This produces a huge, continuous blast of energy in the form of hot gases. These are directed out of the back of the engine, producing some of the engine's thrust. The energy from the combustion is also used to spin the front fan faster, sucking more air in. This air is directed around the outside of the core and forced out of the rear, producing the rest of the engine's thrust.
The 24 precious titanium fan blades, which provide the lion's share of the aircraft's thrust, can now be removed and examined by Chris Thomas and his team for damage.
Is it heavy? Can I have a... I mean, it's not inconsiderable weight, but it's lighter than I thought it would be.
The titanium blades are hollow to save weight.
So what exactly are you looking for when you're doing those inspections?
OK, when I inspect the blade, I inspect the surface of the blade, the leading and trailing edge of the blade for any erosion damage, any chips or dents and corners missing, and any impact damage you can get on the surface of the blade.
Blades can be damaged by hail or bird strikes.
All the blades I've got on the blade root here. You can see all the markings on the blade roots.
Yeah.
Each blade is serialised, and they're put in a specific location to balance the hub.
So much like on a car wheel, say, when you've had something done with your car wheel, it needs to be balanced. So when it's going around a high speed, it's not causing a load of vibration. So if you've had to do some work on one blade, you might have to rebalance the whole thing, not just that blade.
That's right, yeah.
Wow.
Fully loaded, Victor X-Ray needs approximately 120,000 horsepower from its 4 engines to get into the air. That's similar to the power of 1,000 family cars pulling this plane off the ground.
It's just in through this hole here?
Just in through that hole there.
This one here?
That one there, yeah.
And generating that level of thrust is thirsty work.
Wow, this is pretty cramped.
I'm crawling up into the bowels of the 747 with engineer Phil Taylor. He will spend over 2 weeks looking for leaks inside the aircraft's labyrinth of fuel tanks.
So Phil, this is It's the main tank here.
We're in the centre wing tank, which is situated between the two wing sections. Above you is the cabin area with the cabin seating.
Okay.
And you're in the forward mid-section of the aircraft, basically. It holds 65,000 litres.
65,000 litres?
Certainly.
And is that all in this bit here?
No, this is one compartment of 6 compartments going towards the rear of the aircraft.
But there's more than one tank on a plane?
There's 8 in all.
So how much fuel are you looking at there across all of it?
The fuel quantity for the whole aircraft is 216,000 litres.
Well, that is massive. I mean, your average size car is what? I don't know, 60 litres, something like that?
60 litres, so approximately 3,500 cars you could fill with one jumbo full of aviation fuel.
Victor X-Ray is now 2 weeks into its 5-week overhaul, and so far it's on schedule. Engineers have completed over 5,000 of the 12,000 jobs that need to be done before the 747 can be classified as airworthy again. In the cabin, the last remaining floor and wall panels need to be stripped, along with a toilet module.
No, I'm good to go, Mick.
Right, OK.
I've been roped in to help.
OK. Stinks, Mick.
Did tell you that.
Woo!
Oh, you've got gloves on.
Now, Mick, on a lot of old trains, I know that anything that was produced would just be dumped out onto the track. And from that, I think there's developed a sort of urban myth that suggests the same happens on planes. Has that ever been true?
No, it ends up in the aft freights, which is right down the back of there.
Right.
Got 4 tanks.
I last met Mick removing all the seats. And I wondered if working on aircraft for 19 years made him feel more or less comfortable about flying in one.
I love flying anyway, so I mean, it doesn't bother me in the slightest. Yeah. I've always loved flying, but the wife doesn't like flying at all.
Oh.
So, I mean, we'll go on holiday to Lanzarote, something like that, yeah. And we sit there and the flaps will go down, and I'm sort of there, I'll go...
Just grip in your hand.
That's the flaps going down. I should go, shut up, I don't want to know, I don't want to know.
Really?
Yeah.
In an industry where safety is paramount, even a toilet is a highly engineered piece of kit. As an electrical component that could cause a fire, it has to undergo stringent tests before it's passed fit to fly. The tests are carried out at the company's avionics facility outside Cardiff. Here, the hundreds of electronic gadgets used on a plane, from navigational aids and in-flight entertainment remotes to toilet flushing systems, are stripped, tested and calibrated by highly skilled engineers like Martin Jenkins.
So, what happens when you go to the toilet on an aeroplane, Martin?
Right, when you actually finish what you're doing, you press your little button which is on the side of the toilet in the cabin.
It is. There's a massive whooshing noise.
Which is what we heard earlier on the actual rig. You get a spray of water from the top and the vacuum gets created in the bowl and sucks it all away.
Above 16,000 feet, air pressure outside the plane is considerably lower than inside. By opening a small vent, the waste pipe and tank are brought to the same low pressure as outside, effectively creating a vacuum. This means that when a seal on the toilet bowl is opened, anything in the bowl is sucked away into the pipes and waste tanks.
When you're flying, Martin, when you go to the toilet in the air, you must have an ear now for what is the perfect flush.
That's a good point, actually, because sometimes you might get an actuator that is actually working, but not to the full capacity. And as you just said, you can pick it up as you're listening to it. When the actual flush cycle, you might not hear it, but I probably would, yeah. And the other guys that work it as well.
Although it might seem over the top, this level of testing's not without good reason. On a flight, electrical power's at a premium, so even the kettles are tested to make sure they don't use too much electricity and take it away from a more important system. Engineer Simon Orcock is currently checking that these kettles draw the correct current while taking the exact time to reach the precise temperature to make a perfect cup of tea.
We boil it at 83 Celsius plus or minus 2 Celsius.
The board of tea tasters have decided.
If you get a packet of say, PG tips or whatever, there it says boil a kettle.
It says hot but not boiling, doesn't it?
Yeah.
Oh, it's amazing. Even the kettles are over-tested.
Yeah.
When the 747 flew for the first time over 40 years ago, Many of these devices being tested here hadn't even been invented.
As technology has evolved, manually controlled cables and pulleys have been replaced by computer-controlled electronic signals transmitted by wires. Beneath Victor X-Ray's passenger compartment is the cargo bay, surrounded by the 172 miles of wiring that connect all the plane's complex systems.
Just looking around, there are miles and miles of wiring here.
Many of these cables flow from the pilot's controls to these vital computers, currently being examined by avionics engineer Nick Jordai.
The first 747s were designed back in the 60s. I presume those wouldn't have had any of this?
No, the racks were built, but it had totally different boxes on. The boxes were much more primitive than they are now.
So how would what these boxes do now have been done back then?
Well, a lot of the functions done by these boxes used to be done by the flight engineer.
That role's redundant because of these guys?
Done by them, yeah.
There's a thought. Machine taking over man's job.
It's now just 3 weeks until Victor X-Ray is due to fly again. As it's been stripped bare, I've been able to see how the aircraft's intricate flight controls work, delved inside its complex engines, and experienced the impressive mass of its landing gear as it was tested. But could the plane's computers I've just seen control all of these without a pilot?
I'm really interested to see if it could actually fly itself.
I'm heading down to London to see pilot Doug Brown, who flew Victor X-Ray to Cardiff. He's going to demonstrate a 747's autopilot in one of the airline's £8 million flight simulators.
Right, I'll just give you a chance to fly the airplane manually for a little while. As we're climbing away.
Progressing away.
And then what we'll do is we'll put the autopilot in, we'll bring it round and we'll do an automatic approach and an auto land onto this runway.
Okay, so essentially there are 3 planes to be thinking about. One is pulling back to be able to lift off vertically. You've got the steering and the pedals to keep yourself down the runway on that plane. But then you've also got on this horizontal level as well to keep control. What does this control?
All 4 of the engines. So engines 1 to 4, forward thrust on there, and you can see that the engines spool up.
Oh, here we go. It's actually
on there. Yeah. Okay. Now I'm going to put full power on. So now we're coming up towards the speed I'm going to ask you to pull back at.
Oh, really? Oh, there we go.
And rotate. So back on the control column. Don't turn the stick while you're rotating. Keep it in the middle. That's nice. A bit further, I'm going to select the landing gear up.
It's amazing. This is amazing.
Once up, it's a tight 360-degree turn so that we can simulate an automatic landing.
Can you see the airfield there?
I can, straight ahead, yes.
We're going to let the autopilot run through and we'll go right through to an auto land.
Would autopilot be able to do that itself?
The aircraft will land itself if the pilot has set it up properly to do so.
Fine.
The autopilot is now controlling the 747's approach to the runway, altering the pitch and direction of the aircraft. It can also control the level of thrust. But the autopilot cannot extend the wing flaps, which slow the aircraft down, or deploy the crucial landing gear.
50. Now it's going in. You see it?
30.
Okay. Only then can the 747 land itself, although the autopilot cannot apply the brakes.
So now you stick the reverse thrust on?
We do.
Okay. And that?
A little bit of brake. That's it.
Fantastic.
The 747 is a remarkably intelligent machine, but it still requires skilled pilots to fly it. And it's the high level of training which is one of the reasons why flying statistically remains so safe. Another reason is that the airline industry has learnt valuable lessons in rare accidents through an iconic component housed in the tail section of a plane.
Here they are, 2 black boxes. This on the right is the data recorder. records all the telemetry of the flight, and on the left is the voice recorder, which records all the pilots' voices.
The two black boxes are regularly tested at BA's avionics lab, where I met up with engineer John Davies.
This is a black box, but as you can see, it's not actually black, it's painted orange. And that's because it's clearly identified in any incident.
It's a big old tape recorder.
It is a big tape recorder. That's what basically it is. As you can see as well, the tape is actually surrounded by two thermal packs, which are chalk.
Spring-loaded as well?
Spring-loaded as well, yeah. With two thermal packs, which are chalk impregnated with water. So in the event of a fire, that water turns to steam, keeps then that tape at a steam temperature.
OK.
So it won't destroy the tape.
And what sort of temperature range is it specified to?
It should withstand 1,000 degrees C over a 30-minute period of time. That's where aviation fuel burns.
So the bit you're opening now, inside there, that is the precious cargo of...
This is the part they're interested in. It'll record the last 30 minutes of any flight.
It may look archaic, and new airliners have converted to digital, solid-state data storage, but tape still does the trick.
That could contain the most precious of information that will ultimately be fed back to make sure it never happens again.
Exactly, yes, which it has many times.
Yeah.
To comply with comprehensive safety legislation, all aircraft must work to strict maintenance schedules, including detailed tests every year and a complete overhaul every 6 years. At 14 years of age, Victor X-Ray could still have another 10 years of flying ahead of it, but there comes a time when a 747 is just too costly to keep maintaining. Then it's worth more as spare parts than a complete aircraft.
This is part of your flaps, part of the Kruger flaps.
Okay. Mark Gregory is the boss of Air Salvage International.
We're obviously the largest dismantling company in the UK, in fact in Europe.
At Cotswold Airport in Gloucestershire, Mark and his team salvage over 40 aircraft a year.
These here, can we have a closer look at these?
Can, yeah, they are 747 inboard landing gears removed from a 747-400. If it's done a huge amount of landings, then the value of that is kind of dropping. But I think this has done quite a lot of landings. But it's still, still not cheap.
Roughly how much then?
You're probably looking at about $300,000 for a set of landing gears like this.
On a 747, Mark will salvage up to 1,200 parts, which will eventually be sold to airlines around the world. Precision electronics means a second-hand coffee maker could fetch up to £3,000. Even a simple bowl for the toilet could sell for as much as £500.
These are the front screens off the 747. They've got very high value, and I would say probably about $30,000.
What, each?
For each screen, yeah. Because these ones here, obviously, they're heated. They're heated elements running through them. I think they're gold heating elements that go through them.
Well, OK, so in here now you've got... So that there's gold
They're very
running...
thick. They're really thick screens. They're laminated as well. You can just see the elements. See the elements in there.
Yeah, at the top, yeah.
A bit like your car heated front screen as well.
That hits home there. Yeah. The value of the whole industry now.
Yeah, it's massive, absolutely massive.
80% of the salvage value of an aircraft comes from its engines.
This is a 737 engine. This has probably got a resale value of about 1.2 million, I suppose.
Wow.
And going back, the bigger engines at the back, they're a little bit more.
Once all the valuable parts of the 747 have been removed, what's left of the aluminium shell will be tackled. And after almost 3 weeks, Victor X-Ray is now at a similar stage of its overhaul.
18 days ago, this plane was flying passengers around the world. And today, what it looks like inside is a far cry from what it would have been then.
In this skeletal state, there are signs of the 747's evolution.
We're right at the very front of the aircraft here, and above us is the flight deck. And just looking around, even in a plane as modern as the 747, it's surprising to see how much mechanical equipment there is, as well as obviously all the electronics.
Victor X-Ray still uses the Jumbo's original cable and pulley system to control some of the aircraft's most important functions, including the landing gear doors and the rudder.
And then finally, right at the back here, hopefully, yeah, you see the cables heading off through the cabin and off to the rudder. Keeping it mechanical, keeping it simple. Ah, the flight deck. Looks a lot different now without the seats and all the flight instruments.
The Cardiff team now have a tight deadline to turn Victor X-Ray back into a fully working plane. It's booked to go back into service in just over 2 weeks, on the same day the complex process is due to finish. But when a 747 has come to the end of its working life, like this one at Cotswold Airport, there's no turning back for Mark Gregory and his salvage team.
We've removed over 130 tonnes of equipment, and all we're left with is now 100 tonnes of aircraft, which has got very little value because the only value that's there is the metal.
At this point, the final part of the demolition process can begin.
So we'll take the tail off first, chew the tail up. And then we'll work forward. And the outboard of the wings into the fuselage. And then through the rest of the body then. It doesn't take very long. It's about 3 days to do a 747.
It really is all the guts and the veins and everything just being pulled out of the whole machine.
Look at that. Very soon, this 747 is nothing more than a heap of scrap metal. So this is £200 million worth of plane reduced to probably the most expensive pile of scrap I've ever seen in my life. Only a few recognisable fragments of the aircraft remain. So this is a leading edge, and this is...
That's aluminium. Well, here you go, you can see it here.
Yeah.
It's thin, but pretty... I mean...
It takes some battery, though, doesn't it?
Yeah, that's pretty durable.
Then as the wing moves back, it doesn't need to be as strong, so they make it out of this lightweight stuff.
There you go,
yeah. Engineering being led by nature, isn't it? Honeycomb.
Look at this, though. You can see the thickness. It's so thin. It's like that.
Some 747 flight decks are spared demolition to be used as the shell in the construction of flight simulators.
Wow.
Oh, yeah, this is a bit different.
It's like a relic, isn't it? Look at that.
This is proper kind of aviation history, how it all used to be. All these controls here is where flight engineer would have sat when you needed one. Obviously, on Victor X-Ray, that's gone now.
The remaining carcass of a 747 like this still has a recycling value worth up to £35,000. And although it's no longer pure enough to be used again in aircraft construction, as recycled aluminium, it does get to live another day. Once they've separated out the aluminium, it'll be sent away, smelted down and recycled, meaning what was once a fuselage of a 747 could be your next fizzy drink.
Or even the frame of a bicycle.
We're on our way back to Cardiff, where Victor X-Ray should now have been given a new lease of life.
Last time.
Last time indeed.
It's heading out.
Tomorrow evening, it's due to head back into service.
There it is, Victor X-Ray. Completely different, it's all back in. It does smell new.
It does smell new.
Last time I was here, this was all completely open.
Yeah.
It's all on again, the screens are running, good.
Since arriving 5 weeks ago, engineers have replaced over 5,000 separate parts, including 11 brand new toilets. 386 square metres of new carpet has been fitted, along with 285 refurbished seats. And there are 14 brand new first-class seats for
for passengers paying upwards of £5,000 a flight for the luxury.
Wow. Oh, wow. Hey. Oh.
Oh. It's mad to think it does all this and it flies.
In just over 24 hours' time, these seats should be occupied by paying customers en route to South America. So now, for the first time in 5 weeks, Victor X-Ray is towed from the hangar for the final critical tests that need to be carried out to ensure all the parts of the aircraft, including its 4 engines, are working. For Hugh Gibbs, this is the only occasion when an engineer gets to power up a 747 for real.
So will we be moving anywhere when you put it up to almost maximum thrust?
No, we've got the brakes on, and but we can't do more than one engine at full power at a time. We have to do them one at a time.
Really? So if you had all 4, we'd be taking off through the middle of Cardiff Airport?
Yeah. Request permission to carry out a high-power ground run. OK, going up on 1 and 4.
The sensation of being here right now is kind of what you get when you hit turbulence mid-flight, but yet we're here on the runway, sat outside Cardiff Airport. It's just awesome, the power of these things. That was a brilliant, fun experience for me, Hugh, but from a technical perspective, how did it go?
All went well. We had no problems at all. Got the high power, it was lovely and smooth, and it passed all the tests that we needed to do, so.
And does running those engines up to throttle like that get any less exciting any time?
No, I've been doing it for about 5 years now. I still love it.
The following day, and on time, Victor X-Ray is ready to bid farewell to Cardiff. For the engineers, this is the moment when all the hard work pays off.
Quite rewarding, you know, job ownership, you know, especially if you've been on it from start to finish and you think, you look back, I've done that, works, and well, when you see it barreling down the runway as well, 140, 150 knots, you think, I did them bots up.
You know, I've been in the industry of 20 years, and you'll never lose that pride and that feeling inside that, you know, you've been part of producing that product and keeping it safe. And obviously knowing that when the aircraft returns to Heathrow, the customer is then sitting on that aircraft and you know you've done your job well.
After 5 weeks, over 30,000 working hours, and 12,000 separate jobs, Victor X-Ray is ready once again to take to the skies. And for the engineering team, who have painstakingly stripped the aircraft down and built it back up again, there's the satisfaction of knowing it works. This is the indefatigable Lima platform. It's the last remaining offshore rig in one of Britain's most productive gas fields. Made up of 2,500 tons of steel and almost 15 miles of pipework, it's brought over 1 million cubic meters of gas up from deep below the sea. For almost 40 years, it's kept us warm, supplying gas to 5 million homes.
We were the young pioneers in those days. We were the ones bringing oil and gas to the UK. It was exciting.
Now, this giant is about to be demolished. It's going to be an immense engineering challenge.
You just keep watching it and your heart's going thump,
Diamond-coated wires will attack 2-inch thick steel.
It allows the machine to just keep cutting and slicing.
Gas axes, burning at 3,500 degrees centigrade, will bring it to its knees. It's an emotional time for the men who put her up. The North Sea Tigers.
That's 40 years of my life, now gone.
Taking her down will require remarkable technical skills and will provide a unique chance to see right inside this enormous installation.
Okay, could we get that hook reset, please?
This is Engineering Giants. Lima was at the heart of the indefatigable gas field, which was discovered in the 1960s, 70 miles off the Norfolk coast. Now the gas has run out and it's being decommissioned. The whole project will cost £1.5 billion and involve the expertise of more than 1,000 engineers. Removing every last trace of Lima will take 9 months.
I'm Rob Bell. I'm a mechanical engineer, and I've always loved to get my hands on complex machines to discover how they work.
I'm Tom Wigglesworth. I'm a trained electrical engineer with a passion for big machines. As Lima makes her last journey from the North Sea back to British soil, we'll be taking you through every critical stage of the engineering process. And as she's torn apart, we'll uncover the secrets of how one of the world's biggest machines works.
Few people know Lima's secrets, as well as Austin Hand. He worked on her construction at Lowestoft almost 40 years ago.
It started in Middlesbrough where it already slipped on schedule, so Shell decided to bring it from Middlesbrough down here to finish it off.
Right across here?
Just on a barge moored against the quayside, yeah.
Austin's come to meet 2 other Lima veterans, Bill Lindsay and Mick Needham. They haven't seen each other in over 20 years.
For a long time.
How you doing?
I'd like to say we haven't changed much, but I'm doing great, really. Yeah.
Probably the first time I ever come across you was on Lima.
That's right.
You know, that was who I am, and you were the main man.
For me, what's quite special is that you guys were the pioneers, really, of North Sea gas and oil exploration and getting the platforms out there.
It's exciting, but it's a big learning curve as well for all of us. We were only young lads. I joined Shell in 1971 as a 22-year-old, having worked in power stations, and didn't even know what an offshore platform looked like.
Yeah.
5 years later, I'm building them.
Yeah. In them days, the southern North Sea was quite a family unit. We didn't have too many people coming in as like international. It was mainly local lads, and they kind of all stuck together.
Right.
And I think that's these days changed.
I mean, to your friends and family who weren't necessarily working in and around the gas and oil industry, the stories you must have been coming home with every week, there must have just been, what?
It was also difficult for the families because if you're working in a shop or a factory, they've got a perception of what it looks like. But out there, they had no idea what it was like. And
no idea.
I know my oldest girl was only about 4 then, and I had to bring pictures home of a bed and a table with food on it. And she was happy then, but she just thought I was working in the sea.
Mick Needham's involvement with Lima started when she was built.
My relationship with Lima started in 1976, which entailed putting 3 new platforms in, and the first one was in Lima.
More than 30 years later, Mick finds himself back out in the North Sea, working on Lima again, at the very heart of the decommissioning process.
I got a phone call saying, we need a company rep on board the heavy lift vessel Stanislav Yudin taking out the Indy platforms. Would I be interested? And I said, too right, I would.
The challenge of working at sea makes the complex decommissioning process more costly, more difficult, and more dangerous. Massive heavy lifting vessel, the Stanislav Yudin, weighing almost 25,000 tons, has moored up against Lima. This mobile demolition yard costs £500,000 to hire per day and will be home to the 120 engineers who will harvest Lima from the sea.
Their first major job is to plug the wells and sever the gas conductors. The Lima platform had 6 wells, each tapping into a separate section of the gas reservoir 2 miles under the sea. The only way to bore that deep is brace the well in sections as it's drilled. Each time a smaller pipe is passed down and the join sealed with concrete. These are known as conductors. Now, Lima's wells have been plugged in 4 places with cement and the conductors are ready to be cut.
You end up with pipes within pipes within pipes, so you've got concentric rings of pipes. Once the conductors have been cut, you will actually see something that's like a dartboard effect, where you've got concentric circles within each other with concrete between them.
Cutting through these materials would be a challenge on land. But this surgery needs to be carried out 30 metres under the surface of a stormy North Sea.
Morning, gents.
Matteo Mosca helped develop an ingenious cutting solution, one of the many methods used in North Sea decommissioning.
So what have we got on there?
On this wire, which is just a steel strand wire, you got embedded these diamond bits, these elements which are covered with synthetic diamond.
Okay.
Then the wire is constructed as an endless loop, a continuous endless loop.
And it grinds its way through?
Yes, and gives a good finishing. It doesn't alter the physical structure of the metal. Locally, it doesn't heat it.
So can we actually see this cut through?
Yes, that's what it's made for. So let's go.
Back out in the North Sea, this process is happening 30 metres below the surface of the water. These cameras help guide divers as they manoeuvre the diamond wire cutter into place.
Let's get cutting.
The amount of friction created by the cutter can heat up the steel so much that it begins to warp, so it has to be cooled by water. The saw working out on the Indy field has the cold North Sea to do the job. But for this demonstration here on land, cold water must be sprayed on to dissipate the heat.
I mean, the thing for me, which really drives home this is quite a clever piece of kit, well, you've got thousands of tons compressing down. And this cutter allows you to cut across that without it getting jammed.
A jam deep underwater would halt proceedings and cost tens of thousands of pounds to put right.
Well, this, because it cuts all the way around that wire, not just forwards, but also above and beneath it. It allows the machine to just keep cutting and slicing right the way through. It's really impressive cut.
On Lima, with the wells plugged and the conductors cut, they'll be able to move on to a bigger challenge, removing the 2,500-ton platform. This scrapping represents the end of an era. The North Sea veterans who put Lima up know how tough it will be. 34 years ago, as a young man, Austin Hand helped to bring it into the world. Now, he's in charge of decommissioning on one of the North Sea's biggest projects.
Is this you?
That's me and my boss, Gordon Box, who was the guy who actually recruited me into Shell. I've been involved in that sense for 40 years, either design and construct. And initially, my first sort of foray into the offshore business was Indy Lima.
That's Lima in the background.
That's it. It parked in the quayside in Lowestoft after we'd brought it down from Middlesbrough. So that was us beginning to get it ready to go.
The platform has to withstand 15-metre high waves and winds of up to 100 miles an hour. The legs, or jacket, is all important, fixing Lima to the seabed. Removing it is going to be a mammoth task and will require as much engineering ingenuity as went into building her.
So the jacket's basically a frame, and you place it on the seabed, then you put piles in, like pinning it, and you drive the piles with a big hammer into the seabed. Yeah. That is a piling hammer. So it's about 60 feet high. Now, above all these exciting things to do, one of my jobs was to stand out all night with a clicker, counting the number of blows. of the piling hammer.
You got all the good jobs.
Lima's removal from the North Sea will involve taking away not just the jacket, but the piles as well. And before that happens, I want to understand exactly how she was constructed and secured out at sea.
I've got to show you how it works, though.
OK.
Right, so obviously, on Lima, this was done a hell of a lot further out at sea.
Yeah. How do they actually get it out?
They built this on land, the jacket.
Yeah?
They've taken it out on a massive barge, though. But the jacket is basically only there as a guide for the piles. And these are what takes the whole force of the topside. So they go slot down into each of the legs. So on Lima, these piles were being driven 90 foot into the seabed.
Must be a very noisy job.
It is a very noisy job.
That's why they do it so far out at sea, so they don't disturb anyone.
That is going nowhere.
With the legs firmly embedded, the final part of the construction was to add the topside. Now, 40 years on, removing that topside is about to be the biggest test so far for Lima's decommissioning team. Weighing in at 1,350 tonnes, this is the heart of the rig, where the crew lived and worked, processing the gas before piping it to shore. Cutting it off the legs will be an enormous challenge, requiring knowledge, skill, and nerves of steel. The problem is, how do you cut across the legs but still ensure the platform stays in place until craned off?
If for some reason we had a storm blow up and we just did a straight cut, potentially the wind and the weather could vibrate the top sides and start to move the top sides. And if it's just on a flat surface, it could start to move. And potentially, the last thing I want to do is have to go fishing to get the top sides off the seabed.
Lives could be at stake if they get it wrong. And so a simple but ingenious solution is integrated into how they sever the legs.
The cuts are shaped like castle ramparts.
These cuts are absolutely genius and crucial to the whole decommissioning process. Having made the cut through the jacket, the topside's resting on that. What the castellations do gives the whole thing a lot more structural integrity. But when you do need it to be lifted, the crane comes in and it's taken up. Genius.
The final castellated cuts are made to Lima's legs, leaving her 1,300-ton topside precariously balanced on top. The worst thing that could happen at this stage is a storm. The castellations could be brutally put to the test. But the morning sun reveals that Lima's topside is still in place. Now it faces a new test.
This part of the operation is incredibly dangerous. It uses a floating crane that can lift 2,500 tons. That's as much as the Blackpool Tower weighs, which is why it costs almost £500,000 to hire every day. Then, in order to float more than 2,000 tons of steel back to land, a barge is needed. This one is as big as a football pitch. At this moment, there's only one thought running through Mick's mind.
Is it going to be level?
The entire lift is based on complex calculations, which allow the crane to ballast itself against Lima's weight. But these calculations are estimates.
So you're doing a theoretical model of not only the topside's weight, but where the centre of gravity of that topsides is.
And they're about to find out how close to the truth they are. The platform is successfully lifted off its legs for the first time in 30 years. More than 1,000 tons of steel are manoeuvred with precision safely onto the barge.
With stage 1 complete, the engineers will turn their attention to the legs. These are embedded deep into the bedrock and must be cut off below the surface of the seabed. The task is tricky and will require an even more ingenious solution. But as preparation for Lima to leave the indefatigable gas field continues, I want to find out more about why she ended up there in the first place. For geologist John Underhill, gas and oil exploration is a lifetime's work.
I have this strange belief that under the sea, when you go drilling for oil, there exist pools of oil, pockets of gas, large, sealed off sections that we drill and tap into and then it all comes releasing out. Is that true?
Well, it's a popular myth, really, that we float on a reservoir of oil. In reality, it's solid rock with what's called pore space between it, so air pockets that can be filled with gas or with oil.
These air pockets, less than a millimetre in size, fill up with gas over millions of years. The pores make this kind of rock soft and easy to drill. So soft you can even feel it.
I'm moving grains of sand because they're coming apart and they're on my fingers. So that's breaking apart. That is a porous rock.
The very same rock formation that makes up Lima's gas field off the Norfolk coast travels the length of England and emerges on land here at Tynemouth in the northeast.
This is a core from the Southern North Sea, from the Indy field.
Can I hold this precious ingot? And from a sample like this, once it goes into the hands of the geologist and it's tested for all its components, you can then say how rich it is in oil or gas. Or
We can calculate how much gas is in the Indy field, for example, from this and from the mapping of the seismic data.
Geologists calculated that the Indy field contained 5.6 trillion cubic feet of gas, enough to fill nearly 2 million Wembley stadiums.
Under the right conditions, gas is formed from the remains of organic matter, compressed under rock for millions of years. This layer is known as the Carboniferous layer, or source rock. Above this, porous rock holds the gas like water in a sponge, in the gaps between its grains. Finally, a layer of hard, non-porous rock, known as the sealing layer, forms a cap locking in all the gas, until someone drills a well.
There are two types of source rock. One is oil-prone and comes from either marine sediments or lake sediments. The other type is from woody material, coal, that gives a gas-prone source rock.
So it's marine life that gives us oil and then land life that gives us gas?
Primarily, yes.
And here, in the cliff face below Tynemouth Priory, we can see how the source rock lies beneath the sealing layer, identical to that found in the Indy field.
At the base, we've got the Carboniferous, which is the source rock level. Above that, we have the reservoir unit, the yellow sands. And above that, right at the top of the cliff, the recess at the top of the cliff, is the sealing unit, which keeps the gas in the reservoir underneath the North Sea. And all three are exposed here in this cliff line.
Out in the North Sea, with Lima's 1,300-ton topside removed, the next big challenge is to sever the 10-storey high 1,085-ton legs from the seabed. All trace of Lima must be removed to satisfy a so-called clean sea policy, triggered by a dramatic event in the North Sea 17 years ago. The Brent Spar was a gigantic oil storage facility from which oil tankers transported the oil to shore. By 1995, a pipeline had been installed, so it was no longer needed. Shell had a plan to dump it by towing it into the Atlantic and sinking it. Greenpeace saw this as a potential environmental disaster, so they sailed out and took control of the Spar, a protest that would make international news. In a blaze of bad publicity, Shell reversed their decision and instead towed it to shore to be recycled on land and put the rest of the Brent field decommissioning on ice. 17 years later, the process has restarted, and Austin Hand, who began his offshore career building Lima, is in charge.
Did that kind of act as a precedence for now how all the fields and the platforms are decommissioned?
We thought it was a reasonable and logical thing to do, to take it out to sea, 2.5 miles down in the Atlantic, and place it in this kind of valley on the seabed. We didn't do a very good job of explaining that. So basically that resulted in the Oslo-Paris Convention of 1998 that said, roughly speaking, you put them there, you take them away. Okay. A clean seas policy. Okay. And that's what Greenpeace drove for, and that's what they succeeded in getting.
There's so much involved in this that the cost of decommissioning just must be enormous.
Austin's estimate, Austin's view, $100 billion.
Of decommissioning?
In the UK. There are those that would say, I don't believe you, Austin, you've overstated it. We'll see who's right in the end.
Because of the clean seas policy, out in the North Sea, the Lima engineers now face a really difficult challenge. Cutting the legs of the jacket to remove it from the seabed in a way that leaves no trace that it was ever there.
To achieve this, the jacket legs must be cut off 3 meters below the seabed. This means the only way to cut the legs is to sever them from the inside.
It's a job that demands a very special type of cutter. As world expert George Jack explains, there's no blade, no flame, just water and grit. Is it the seawater that you're using there as your...
Yeah, we take filtered seawater in through our pumps,
yeah.
Pump it, take up the high pressure, and then introduce the abrasive to it as well. Yeah, that's the actual garnet we introduced to the water.
Oh, that's pretty hard stuff, is it?
Yeah. Yeah.
Garnet is a dark red, silicon-based mineral. Although large crystals are used in jewellery, some types possess strong atomic bonds, which make them very hard, and ideal as industrial abrasives.
If you don't have that in your water, there's not enough friction to cut through the actual metal.
Okay. George is about to demonstrate to me the power of cutting with water and garnets.
This is the control room. This is where we control the water pressure, the grit monitor.
Okay, so what pressure are we at here at the moment?
Just now we're sitting at just 6,000 psi.
Okay. That's 300 to 400 times greater than your typical water supply at home. So abrasive on.
Yep, this is when you're introducing the grit into the system, the pressure comes up.
There we go. Look at that.
You'll know when as soon as it starts coming through, you'll see the water coming underneath.
Whoa, now you can see it's just gone through. So that's 50 millimetres of solid steel. That's just
50 millimetres, yeah.
So compared to, say, a high-pressure jet hose that you might get for your washing your car or doing your patio from the hardware store,
yeah.
If you tried to do that with this thing, you'd probably do more damage than good, right?
Oh, yeah. The pressure, we have to barely read on one of these gauges. The first line on that, go up in thousands.
I'm not quite sure what kind of cut I'm expecting. Is it going to be a clean cut? Is it going to be quite jagged? I don't know. Here we go.
This is 10 minutes worth of cutting time.
That's clean. That's a really straight, clean cut.
Yeah.
The old Paul Daniels, Debbie McGee, it's gone right the way through.
Yep.
Right, so this is not for domestic use?
No, not for domestic use, I'm afraid.
The Lima engineers are ready for the high-pressure water cutter. With the top side removed, they're able to lower it down, right inside the legs. In theory, if the severance isn't complete, the crane could pull the Stanislav Yudin over. In practice, fail-safe mechanisms would prevail, but an incomplete severance could still cost millions.
We control it from the top side using our hydraulics and everything.
Okay.
And it'll do a 360 degrees subsea, just 3 meters below the seabed.
Before they begin the cutting, every precaution must be taken. The system is pressurised to 6,000 pounds per square inch. Any leak or breach could be deadly. An exclusion zone around the cutter is strictly enforced.
Because we've got high pressure hoses running across the deck, if you put your hand up like that, you're not going to have anything left.
Calculations estimate that the 360-degree cut of each leg should take 75 minutes. All Mick can do now is time it and hope. Once the allotted time has been given to each leg, special slings are attached.
So all the slings are, they're not just something you get off the shelf. All these slings are engineered and designed and built to the length required.
Now the crane must ballast itself against an unknown payload. Up to 300 tons of extra weight in marine life could have accumulated over 4 decades, making the jacket 1,400 tons, as heavy as 7 jumbo jets. All this makes the calculations for the stability of the crane more and more difficult. Puts the ballasting power of the Stanislav Yudin yet further to the test, and their stability in more jeopardy.
And then the big tense moment for everybody. Because we are now going to start to lift the jacket, but there's one thing we can't do. We can't actually 100% guarantee they're cut by going to have a look at them. You hear the crane driver, he starts taking the weight on the crane. 1,200, 1,400 tons, somewhere in that region. And if he gets to 1,400 ton and then he starts saying, I'm at 1,450 now, you're thinking, I hope this is going to move shortly. And your heart's probably going thump, thump, thump. And then all of a sudden, it just seems to go, oh. And it's a great sight, that. And it's a great relief.
After the final lift, engineers work through the night to fasten Lima safely to the barge, upon which she'll make her final journey.
And that was it. It was an end of an era for not only myself, but for so many people that have worked on the indie field throughout the last 40 years.
In the dead of night, she leaves the indie field behind forever and sets off on the 200-mile journey home to the northeast. Mick's relationship with Lima has finally come to an end.
India produced for so long, brought lots of people work, and more than that, lots of great friends and happy memories. I think that's what'll stick. I'm no joking, Hope. Ah, dear. I can't believe that. Excuse me.
But for Lima, this marks the start of the next phase of deconstruction. As dawn breaks over the horizon, Lima arrives at the mouth of the River Tyne. From here, she'll be taken to the famous Swan Hunter shipyard for demolition.
It's amazing to think something like Lima, how important that was to us. We just don't really consider that at all, really. It's delivering all that gas to our homes, keeping us warm, cooking our food.
Well, the indie field actually produced enough gas in its lifetime to power the UK for a year and a half.
Just in one gas field?
Yeah.
At the Swan Hunter shipyard, they must wait for the tide to be just the right height so the barge is level with the quay. Only then can the painstaking process of sliding over 2,000 tons of steel off the barge onto land begin.
You don't see one of them come over every day, do you?
4 remotely controlled bogies, with a total of 56 axles, each capable of supporting 36 tons of weight.
Fantastic.
Manoeuvre Lima into her final resting place. Now, the next chapter in her story is about to begin. Ivan Rain is Geordie born and bred, and is another person whose relationship with Lima and her sister platforms goes back to their construction in the 1970s.
But you didn't have to wear all this kind of stuff back in the 70s, did you?
Yeah, we did, but once you got offshore, if you ever mentioned the word safety, you're on the next helicopter home again.
He too has come a complete circle. He's now here to oversee the demolition and recycling of Lima.
All these pipes and valves and kind of meters, everything we can see around, it's all dedicated to getting that gas up out of here.
The main function of this platform is to gather gas from the seabed, and the gas will be brought up through 6 pipes, brought into this system here, and then redirected to another complex where it is collected, and then it's sent to the UK mainland for refining, and then it gets redistributed throughout the UK, and it comes into your house, and that's what you use for cooking your roast beef on a Sunday.
For Veolia's recycling team in charge of the demolition, this is no ordinary takedown job.
So this has been out in the North Sea for 40 years. Where do you start in taking it all apart and recycling it?
The heli deck will be cut off and pulled over, and then they'll start dismantling it section by section. Once that's flattened, they'll start cutting it up into very manageable pieces. And the smaller the pieces, the better the value they get for recycling, for transport off the site.
All right, so now we're talking money. Typically, you know, what are we looking at for recycling this whole platform?
Could be looking anything from 180 to 200,000 pounds.
Wow.
Scrap value.
After 40 years of service, providing gas to millions of people, and jobs and even a home to hundreds of North Sea tigers, Lima is finally about to be brought to her knees.
First, her infrastructure is weakened by strategic cuts. Next, it's time for the excavators to really get to work. Steel wires are attached to the helideck, and the machines go into reverse.
This red accommodation module is next for demolition. Its fixings to Lima's frame have been severed, and the excavators are standing by. Cubitt spent 4 years living and working on Lima as an electrical engineer. It's almost 19 years to the day since he last saw her.
The place is incredible. It's like a bomb. A bomb has hit the place. In fact, it's bordering on unrecognisable.
I don't want to pull any more emotional punches on you, Mick, but I think that is your old bedroom, that red tin shack over there.
I'm afraid so. I spent several, in effect, the equivalent to 2 years' worth. So it's somewhat...
4 years, half on, half off.
Yeah, that's right. Yeah. Some 700 nights spent in that little tin box.
So we've had to walk into your accommodation block, Mick. This is home sweet home.
Home sweet home looks fairly devastating to me. It's been... really had the insides ripped out of it now.
True. So this was the living area then, Mick, was it? This is where you passed the time?
Well, prior to the introduction of satellite television, we used to show films that were hired in by the company.
Like your own little blockbuster?
Yeah.
So, Mick, this must have been pretty cramped. How many people lived in here?
This was accommodation for 8 people, two lots of bunks. The shower for all 4 was in here. That's the shower tray with a wash basin placed just here.
Shower, wash basin.
And that was it. That was your emergency exit.
So, Mick, it's the middle of the night. You're asleep in your comfortable abode, and there's an emergency alarm. The worst case scenario. What's the order of service?
3 offs. The 3 offs being block off, where you would block in all the wells, stop the gas coming onto the platform. You would then vent off.
And what's the 3rd off?
You just off. Follow me.
Okay. Quickly, Mick. It's an emergency situation.
For Mick's Lima colleagues, reunited in Lowestoft for the first time in over 20 years, all that's left are photos and shared memories of their incredible offshore lives.
Is that you?
That's me on Lima.
How many times would you have been offshore at that stage, do you reckon?
Probably not many.
Yeah.
Yeah, we used to fish, didn't we, Tony?
Sure, there is some entertainment to be had.
Made our own entertainment of them.
What was the food supplies like? I mean, did you eat well?
Ate very well, but you would have a choice of a fillet steak, a bit of fish.
That's a decent spread, that, isn't it?
It is indeed.
Christmas crackers.
Yeah.
Explosive
devices offshore.
If you had a good chef, you had a good platform,
Yeah.
and you had a productive platform.
That's one thing I really take away from this whole process is it isn't just the hardware. It isn't just all the steel and everything there. It's the family of all the people who've built it, worked on it. How does it feel now that particular field and Lima platform's not there anymore, is it? Does it kind of sit with you? Does it rest with you, or...?
When you finish, you think, you know, that's 40 years of my life.
Yeah.
You know, now gone.
You just realise how old you're bloody getting.
Back at the Swan Hunter shipyard, another relic of the glory days of the North Sea has been uncovered. A stark reminder of just how treacherous it can be.
So this looks like a horror story, Mick, but I believe it was just the heli deck. When they removed it, it smashed into the front there. But this is your survival raft, isn't it?
Yes, this was the Bruger capsule, as it was known on the platform. Awful thing to steer, being circular, and an awful thing to ride in.
Were you the captain, were you?
I have been done the coxswain's training on here, and I've been to sea with guys who are happily throwing up, and it is not the best place to be, even with a dozen guys in, when you've got a couple of them thrown up into their hard hat.
I'm hoping that years of training means that my Lima veterans have grown stronger stomachs, because I'm about to get my first taste of the Brooker pod experience.
And this is exactly the kind of one you had up on Lima, is it?
Absolutely, yes, identical.
Identical. Well, luxurious, was it?
Well, that's how we became friends, you know.
Pods like these have safely evacuated more than 2,000 people in over 60 incidents around the world since Lima was built.
So how long since you guys have been in one of these then?
For me, it would have been 1978 in this particular type.
I've been given the job of releasing the capsule, and it's fair to say that the speed of the response takes me by surprise.
Right, we're off.
They were designed for the Gulf of Mexico, but the bobbing donut was no match for the waves and currents of an undulating North Sea. The survival pods, still vital for an industry which has claimed hundreds of lives, are now usually boat-shaped. I'm being shown the ropes by Nick Goldspink, who's been teaching North Sea Tigers how to navigate these pods since 1989.
I mean, we're moving around like a boat, but still this round shape seems like a very odd design for a boat to me.
Yeah, it's partly to do with strength, and it's partly to do with ease of operation. The traditional style of lifeboat has got a cable at the front and the back, and there's a chance that that can hang up. There is no chance and no possibility to that with this shape of boat. Obviously, there is a compromise to the shape, and that is that they do bob around like a cork.
Round boat, though, so how do you even steer this thing?
Yeah, well, that is more difficult than a traditional lifeboat shape, but the advantage of that is they're very manoeuvrable. But she's steered basically from the tiller here, which again is unusual in a lifeboat to steer a boat from the front.
If you were to evacuate, how long would you be able to survive in a craft like this?
A fairly long while would be the answer to that. I mean, there's enough water and food for a week.
I would not want to be stuck in here for a week with 27 other people.
You'd get to know them fairly well.
You would become quite an intimate team.
So how was that, gents? Bring back a few memories?
Yep.
I have to say, 20 years on, I never thought I'd be back in one of them.
Back on Tyneside, there's nothing ship-shaped about Lima, which has been slowly cut down girder by girder, making it no longer possible to trace the pathway that gas would have taken, snaking through miles of Lima's pipework from under the sea to our kitchen hobs. So to solve the mystery of how she worked, I'm going to see an offshore platform in action and trace the fossil fuel route.
A little bit anxious. Never been on a helicopter before.
Thanks to gas and oil, Aberdeen Heliport is Europe's busiest, ferrying almost 500,000 passengers offshore every year. Across the North Sea, more than 100 lives have been lost since air transfers began, which is why every possible safety technique is used.
I'm terrified. Absolutely terrified.
In the event of the helicopter ditching, this suit will increase my survival time in the freezing North Sea from just minutes to about 7 hours. But I hope I don't have to put it to the test. After an hour of seeing nothing but sea, a platform comes into view. 100 miles offshore from Aberdeen in the northern North Sea, this is Nelson, which produces both gas and oil. The fossil fuels pathway on Nelson is very similar to Lima's gas pathway, so I'm going to track the route from under the sea to our homes and explore how current technology works. While Lima had 6 wells, Nelson has drilled 28. Nelson's manager, Nick McLeod, is going to show me the drill floor.
Okay.
Wow! Pretty impressive drills there. Our wells here could go down as far as 20,000 feet.
20,000 feet?
Yeah. And eventually we get down to what's called the pay zone, which is the area, the pay zone. That's where the money is.
Yeah.
That's where the oil and gas is.
Okay. What happens then? It calls spurts up, doesn't it? And everyone cheers. Is that right?
In the old days, hopefully not these days.
The first crucial stage for the fuel that emerges is the well bay.
Everything's moving about and juddering. Really noisy. Absolutely unbelievable. It's unbelievable to consider that they've made this size of machine. It's even more incredible when you realise that we're 100 miles off the coast.
Production engineer Murdo MacDonald is here to explain the first step of the fossil fuels pathway.
Oh, there's not a lot of room in here.
Which involves something known in the trade as a Christmas tree.
Why is it actually called a Christmas tree?
Maybe it's because they look like they've got branches coming off them. You've got all the gauges hanging off.
You've got quite an imagination, if you...
Yeah, you've got quite a strong imagination. You have to with 2 weeks offshore.
Yeah, that's what it is.
When a well's drilled, the raw fuel comes up the conductors into the well bay. On Lima, this was gas. On Nelson, it's gas and oil. Here, the Christmas trees, large assemblies of valves and gauges, help control the flow of oil and gas entering the platform. I'm ready for my first offshore job.
5 turns. Oh, 1, 2, 3, 4. 5 turns. What have I done?
Just close the choking about 5%.
Just closed the choking 5%, which has restricted the oil flow coming up the...
Absolutely.
Stage 2 of the pathway is all about separating what emerges from the well into its constituent parts.
Like a science fiction film.
When a well is drilled, oil comes up the conductors into the well bay, but it's not pure oil. It's a mixture of oil, gas, and water. In order to extract the valuable oil and collect the gas, the whole mixture is sent to one of the most important devices on the platform, the separator.
I've made a model of Nelson's separator to explain to Rob how it works.
It's bafflingly simple. We have here a bucket, which to the casual observer appears to be generic brand cola mixed with vegetable oil, which is actually exactly the same as oil, water and gas, right? That's what's coming up from the bottom of the sea.
So we've got a pump, but normally that's got enough pressure to be forcing itself up.
Exactly, that would be pushed up under its own steam.
Yeah.
So what you do, you separate them out. The gas will naturally float off to the top.
Yep.
Lighter than both of them.
So that'll normally be tapped and off into wherever else it needs.
That'll be tapped and processed, yeah. Water is heavier than oil. So this weir is very important because the oil floats on the water.
OK, you can see that easily here. So the brown stuff is the water and the creamy stuff is your oil.
Exactly. So because the oil is floating on the water, it flows over the top of this weir, creating this secondary chamber here, which is pretty much all oil. So coming out of here, you get pure oil. Coming out of the bottom of this section, you get flat cola or water.
Yeah.
Coming out the top, gas.
Gas.
This separation stage of the fossil fuels pathway is vitally important because it tells the energy company how much gas and oil they're producing. To do this, every day each well is taken out of production and diverted into the test separator.
You too? How's it going?
In the control room, Pete O'Connor is monitoring the results.
So that's the production valve there, the diverter valve, which is open. That's the test one, which is shut. So by putting it into the test separator, it lets us know how the well's performing, how much oil it's producing, how much water, how much gas it's producing. All our wells now are starting to water out all over 80% water.
That didn't used to be the case?
No, they all gradually decline in oil production.
So the test separator is actually testing the mix of oil to gas to water?
For each individual well.
Yeah.
We have a spot rate there, which at the moment can tell you we're doing 19,357 barrels near enough today, at the moment.
Wow. At that rate, Nelson produces oil worth around £1.5 million a day. Not a bad return. The third and final stage of the fossil fuels pathway is exporting it. Water is cleaned and pumped overboard. Oil is cleaned and then pumped down the export pipeline to shore. But it's not all over for the gas. Some is exported to gas terminals. Excess is burnt off on the iconic flare stack. But most of it is diverted to something known as the gas lift to do an important job.
Because of the weight of the ocean on this trapped reservoir of hydrocarbons, it's all under pressure. It's kind of like this. So the moment the drill pierces it,
wow, you've got
the oil comes out. Now, obviously, quite soon it loses pressure. So once they've been tapping the oil off,
so it becomes like the field becomes flat.
Yes, exactly. It becomes flat. It becomes devoid of pressure.
Yeah.
So what you do, instead of pumping it up, you push gas down into the reservoir, which makes the oil light because it's got gas in it, which then sends it back up. You basically make the world's biggest soda stream.
The gas collected from the separator is compressed, repressurised, and then re-injected back down the well via the Christmas tree, forcing more precious oil up. The force required to do this is huge. On the platform, Murdo shows me where they get it from. It's a gas compressor, which is essentially a jet engine, and it's one of the noisiest things I've ever experienced.
The engine drives the power turbine that drives the gas compressor. The gas compressor takes the pressure from 5 bar from the production separator, takes it all the way up to 147 bar.
That's 147 times atmospheric pressure.
That 147 bar is then used in the header to re-inject back down the wells to lift the oil back up again.
Like they're a powerful blow, aren't they, those jet engines?
I would say it's quite a blow, all right. Yeah.
But while Nelson's conductors are still full of North Sea gas, Lima's conductors now lie severed from the rest of the platform on the quayside at the Swan Hunter Yard near Newcastle. And demolishing them is going to be a feat in itself. Because of the way the wells are drilled and constructed, they end up with pipes within pipes within pipes, all sealed with thick layers of cement. Turning this into small pieces of scrap metal requires a process known as bombing. First, the gas axe is used to cut along both sides of the long steel conductor. Then, to get at the inner pipes, the excavator steps in. Once it's made short work of the concrete, the inner steel pipes are revealed and the process starts all over again. With over a third of a kilometre of conductors to scrap, it's a lengthy process.
Meanwhile, on the other side of the yard, only Lima's legs, or jacket as it's known, still remain. Built from over 1,000 tons of high-grade steel, it must be broken up into small chunks to be recycled. The first stage is to bring the structure to its knees. Strategic cuts must be made so the legs collapse neatly. But it's a dangerous job. As soon as a cut is made, the platform is weakened and may fall at any time.
So are you guys responsible for felling the legs?
Yes, we are, yeah.
I wouldn't like to be the guy who does the final cut. Who's in charge of that?
Whoever wants to do it. The backside gets a bit twitchy when the
cutting the final.
Well
doing the final
understand.
cut,
I mean,
yes.
I think if it was me, at the moment the axe is finished, I'd be turning and running. Do you actually...
No, there's no need to run.
In a carefully controlled and calculated procedure, tow lines attached to the top of the jacket will be used to pull it over. This is the first time this method has been attempted anywhere in the world.
We attach 2 ropes either side of the jacket and a safety rope to the very back of the jacket just to stop the bike legs toppling the wrong way.
The engineers have put down a bed of earth for the legs to collapse onto to cushion the impact.
Got 2 lines, haven't they?
Yeah, 2 pulling lines. These guys will take the tension up on the wear. Just give it a little tug.
It's quite exciting, just the anticipation of it before it's going to come down.
Everything clear?
Clear.
Don't let anything in now, because we're about ready.
All clear, Mick.
If the 30-metre-high back legs were to fall in the wrong direction, they could land on a factory behind the shipyard.
Still excited to see these come down?
I love it.
Brilliant.
Well done.
Brilliant. That was awesome. Congratulations.
And that's the way to do it.
Things perfect, lad.
The demolition of this jacket for recycling is the final act in the scrapping of the Lima platform.
Although veteran Lima engineer Austin Hand is working in decommissioning, he has not seen Lima, the platform he cut his teeth on, for 20 years.
Well, there she is now.
Wow. I'm so used to building things, so to see it dismantled and in pieces is just...
So you're probably quite used to it in this condition, in a sense.
I can still see the module, yeah.
Just on the different curve of its life.
Yeah, now that really reminds me of going on and off that barge for months to get it completed. Just walking over a gangplank and working 12, 14-hour days every day. But it was fun and exciting, so yeah, that gives me a bit of a buzz. You know, we were the young pioneers in those days. We were the ones bringing oil and gas to the UK. It was exciting. Good memories.
So I've seen, Austin, as this process has unfolded, I've seen the huge machine of Lima being reduced to small piles of steel rubble, and I was surprised to see so much timber on show. Can you tell me a bit about this?
Well, they used to say in my day that the rigs were made of wood and the men were made of steel, but that's not actually true. So what this was, we covered the main steel deck with this timber, so that when you were lifting stuff off supply boats and landing it on the platform, you had some absorption material that avoided sort of damaging the deck or even the container.
So all this timber here was to provide you with a huge cushioned area to protect the whole thing, like a massive chopping board in a way.
Absolutely, yeah.
This steel tubing once formed the jacket that supported the topside. It's now been broken up into sections, ready to be recycled. But to the expert eye, even these fragments reveal the challenges of these early pioneering designs.
In the 70s, sometimes the quality wasn't great. So this is a good example here.
Yep.
Now, this is a very tough angle for a welder to get in at these points.
You get right down in there.
Exactly. So, you know, in an ideal world, that brace would have been at a less of an angle, but very often the designers just wanted it to be structurally robust.
Okay.
And then when it arrived for us to deal with it in the construction yard, you think, wow, why did they do that?
Yes.
And
so on paper, mathematically, it makes perfect sense.
Exactly, but sometimes it wasn't constructible. But again, this was a learning process that we would feed that back in to the next jacket and say, can we do this slightly differently? And that's how we evolved the industry, getting better and better and making it easier to be sure these welds would sound and solid. All these things had to be considered, even with a relatively simple structure like a jacket.
For the final time, the excavators pull on Lima's infrastructure to bring down her last story.
Oh, the leg's gonna go. There she goes.
very, very sad to see that something that you built when you were a 25-year-old, you're pulling it to bits when you're a 59-year-old. And it just shows you time moves on and nothing stands still.
Lima is now unrecognizable, just heaps of rubble and thousands of tons of scrap steel. Amazingly, some 99% of this will be recycled. The wood from the decks is pulped and made into paper. Even the 300 tons of algae that collected on the legs will be recycled for compost. But most lucrative is the steel. Once the various grades have been separated out, it's then smelted and made into new girders and pipes. Fittingly, just half a mile down the road, steel from the smelted remains of machines like Lima are being used to build this.
A brand new 21st century platform. And to put it in perspective, whereas Lima weighed a few hundred tons, this weighs in at a whopping 12,000 tons.
Platforms like this are giving the North Sea a new lease of life. But Lima and its gas field are now just a memory. Removing it cost more than £200 million, took 2 years and over 1 million staff hours to recycle 2,000 tons of steel, 311 tons of algae, find homes for 2 generators and scrap 2 toilets and 12 well-worn bunks.
And ironically, some of the North Sea Tigers, who pioneered offshore platform installation, are now involved in the biggest new North Sea industry, taking them back down again.
Oh. 32,000 tons of steel. 7 decks, each the length of a football pitch. 4 engines, burning 2,500 litres of fuel an hour.
So when you're out at sea, I can't imagine the noise that makes.
One massive feat of engineering. The North Sea ferry, the Pride of Bruges.
Wow. Can't get too much more up close and personal with a ship than we are, yeah.
Battered by the sea, for 25 years, it's being taken out of the water for the biggest overhaul of its life. As key parts are stripped down, there's a unique chance to explore deep within its hidden features.
We're as far as any sensible person would go.
Every complex system must be rigorously tested and repaired before it can return to service.
If you've got a high clearance, you could actually lose your rudder.
So these checks,
they're very important. They're very important.
A 120-strong team of highly skilled engineers take on the challenge.
To replace all that is a massive job.
They must examine over 1,000 separate parts and repair over 10,000 square meters of steel hull.
This wasn't being done.
The steel itself will just deteriorate.
And we'll reveal what happens to these giants when they reach the end of their working lives.
They're just getting munched up by this shearer.
And how in their death, they're given a new lease of life.
Wow. It's just an incredible firework display.
This is Engineering Giants.
I'm Rob Bell. I'm a mechanical engineer, and I've always loved to get my hands on complex machines to discover how they work.
I'm Tom Wigglesworth. I'm a trained electrical engineer with a passion for big machines. And this is the Pride of Bruges, the North Sea ferry that's going to help us explore exactly how a ship works.
It's arriving in Newcastle, where it will spend the next 3 weeks being stripped down.
Pride of Bruges, town pilot, we're coming to you now.
God, we're like a mouse coming alongside an elephant here. Look at this. All the ship's key components, including its engines, propellers, rudders and hull, will require detailed checks and repairs. The problem is that many of the most important parts of the ferry are underwater.
Before any of the checks can take place, the first challenge is actually to get this beast into the dock. And that's no mean feat.
Engineers won't know the extent of the work ahead of them until all 32,000 tons, the weight of over 2,000 double-decker buses, are safely out of the sea. And to do that, the ship must now be precisely manoeuvred into the dry dock facility at the A&P shipyard on the Tyne.
The job of all the guys here around the dock is to get this ship absolutely central and in exactly the right position in the dock. On the bottom of the dock underneath the water are what's called docking blocks, and they've been laid out in exactly the right position for the design of this ship, the Pride of Bruges.
Earlier today, I met up with site manager John Leckie to find out how his team was going to accomplish this engineering feat.
These blocks that the ship will sit on, they've been put in particular positions for this ship, in accordance with its docking plan.
The metre-high steel bases are topped with oak blocks, which cushion the immense weight of the ferry, preventing damage to its hull while enabling engineers to work right underneath the ship. Once they're in place, the team can flood the dock.
If by some means it started right now, will we have time to get out?
How quick a runner are you?
Well, pretty quick, but...
Using water from the river next door, fed by gravity, the dock is flooded with 133 million litres of water, equivalent to 53 Olympic-sized swimming pools.
Oh, wow. Look at it come out. It's absolutely flooding out. That did not take long at all.
It takes another 3 hours before the water in the dock is at the same level as the river outside. Then, the gate can be dropped. Engineers have calculated where the hull needs to be positioned in relation to the dock so that the ship ends up exactly above the blocks. Tonight, this task is particularly challenging as there's a strong crosswind.
This is quite a tense moment, and it was the bit that they weren't sure whether they were going to actually carry out tonight because it was so windy.
Come back down to one on the starboard side.
With the margin of error less than a metre, the ferry is attached by steel lines to winches known as mules, so that the ship can be precisely manoeuvred from a central control tower.
Okay, Alan.
Hello, we're just starting to drift back a little bit there now.
It's such high precision work. And with the wind coming across as well, it's certainly not easy.
Caught by a gust of wind, the ferry is pushed perilously close to the edge of the dock.
Okay, look at this war, Sean, this war.
Any damage sustained to the ship on its way into dock could cost millions and set the whole schedule back days.
Sean, let's see where the formula oil, please. Take a bit stronger.
Okay, Mick, so let's go. Hello, we're drifting back here now to the starboard side. We're about 2 metres to the port side.
Finally, after 2 hours of manoeuvring, the team get the ferry into position and raise the gate.
Next comes the most dangerous part of the operation. If the ship is not in exactly the correct position above the blocks as the water is pumped out, the hull could be badly damaged. These 3 electric pumps will drain the 133 million litres of water out of the dock.
Each one pumps out 18,500 tons of water an hour.
After another 4 hours, it becomes clear that the engineering team's measurements are spot on as the Pride of Bruges finally comes to rest on its blocks.
Wow. Can't get too much more up close and personal with the ship than we are here. And you can see the effect that the weight of this ship, all 32,000 tons of steel, has had on these docking blocks. It's very intimidating.
With the Pride of Bruges now out of the water, for the first time in years, engineers, including site manager John Leckie, can examine and begin to repair the most important part of the ship, its hull.
So, John, now we're this close to the vessel, it strikes me that there's actually very little of it under the water.
The volume displaced by what's under the water equals the weight of the vessel in its entirety. So there's actually quite a lot under the water, especially with this type of ship.
So if you lowered it into the water, as it started to enter the water, it would displace 1 ton, 2 ton, 3 ton, 4 ton. When that displacement weight matches the weight of the ship, it stops.
Yeah.
It floats.
Sits and floats, yeah.
The shape of a ship's hull depends on the type of work it's designed to carry out. For speed, V-shaped hulls are best, enabling ships to cut through the water, minimising drag. For stability, a boxy U-shaped design like our ferry is better, creating more cargo space and minimising rocking. But the shape of a ship's hull isn't enough on its own to ensure its stability and seaworthiness. A perfect level of buoyancy is also needed, and to make that happen, the ferry can pump up to 2,200 tons of seawater into the network of ballast tanks that run throughout the lower part of its hull.
The ship is designed to sit at a certain depth in the water. If the ship was empty, carrying no load, it would actually sit so high up in the water that it would appear unstable. Now, this is a bit of an extreme example. That's not classic ship shape. We can make even this sit in the water with a good degree of stability if we put enough ballast in it and cause it to lower its buoyancy point, like that.
While the dock was being drained, the ballast tanks on the Pride of Bruges were emptied, so that engineers could begin the filthy job of cleaning out the water inlets, known as sea boxes.
Hey up, there's a man in there. Is he a contractor or is he just dodging a fare?
Engineer Colin Grant has the job of ensuring that this major overhaul runs smoothly.
Guys are working up there, cleaning the mud and everything that accumulates, because eventually it would clog up and the ship's got a problem.
So when the ship needs a drink, this is its mouth?
It is, as it has to pull in cooling water all the time.
Yeah, for the engine.
And put it out again, exactly.
Yeah.
The forward end of the engine room has rows and rows of big pumps for different purposes. Some to circulate water around the engines, and there's lots of engines in there, and some to push the ballast water up when it's required, right through the length of the ship.
Once the sea boxes have been cleaned, engineers will have to squeeze through tight access holes as they venture deeper into the ship's ballast tank system to inspect and repair their steel interior against corrosion.
The thing that makes this one stand out for me is that we have a great big ship here, and you've got the daftest access to it you've ever come across in your life.
Colin qualified as an engineer at the Ministry of Defence and has always been passionate about ships.
There are all sorts of plans of the ships, but the one that we need for this exercise is this.
Before Colin's team can begin examining the ship's labyrinth of ballast tanks, he first needs to check that they're safe and that no water remains inside them.
So normally, when the ship's out at sea, this would all be filled with water?
It would, yes.
Part of the ballast tank system?
Yep.
It's pretty pokey around here.
Yep.
The tanks are divided into a series of smaller pockets designed to prevent the volume of water, equivalent to an Olympic-sized swimming pool, from sloshing around the hull and making the ship unstable.
So Colin, now we're pretty much right down inside the forepeak now.
We're as far as any sensible person would go.
Moving around inside these tanks is cramped and claustrophobic.
As part of the check, you'd have engineers coming down here to do what kind of maintenance?
The condition of the shell has to be checked. It's steel, it rusts, and therefore it has to be monitored, looked at. All ships of this kind, in effect, are two things. You've got the lower part that sits in the water, and that's the real ship. It's got all the machinery and everything, yes. All the stuff up a height, the passengers go in and the cars go in and all that stuff, is cargo on the actual ship, even though it's a permanent part of it.
Yeah.
This is the bit that has to do the work of getting from here to there safely.
And that safety depends on making sure that the hull sits at the correct level in the water. Too heavy a load and the ship could become dangerously low in the water and susceptible to swamping. So the simple horizontal line across the circle, the plimsoll line, indicates the maximum load level.
The other little marks there are indicators for different particular conditions, which would be fresh water and salt water, or, you know.
And is that because fresh water and salt water offer different buoyancies?
Different densities. The salt water is more buoyant, it's denser than fresh water. And similarly, cold water is more buoyant than warm water.
Cold water is more buoyant than warm water?
Yeah.
I never knew that.
Correct, yes.
And the Bruges is designed to compensate for these variables by pumping water in or out of its ballast tanks.
Oh, freedom.
A part of this ship that I'm keen to get out of.
I don't envy the guys who have to actually do their work down there. Whew. Oh, that's hard work. How's that, Colin? One of the perks of the jobs?
Wouldn't do without it. Love it. I wouldn't want everybody to know this, but that is one of the attractions of the job. I get to go places where normally nobody goes.
It's brilliant. It's a real privilege to come along with you.
I went to become an engineer because anything internal combustion, anything that goes banging up and down and round, and the bigger the better.
It's in the areas of the ship beneath the waterline that most of the important maintenance work over the next 3 weeks will take place. This is where many of the ship's most vital components are located, and where I found P&O's chief engineer Hans Pronk. He was part of the team that took delivery of the Pride of Bruges 25 years ago.
My roots are at sea, so seawater is in the veins.
Yeah.
Hans's engineering team are about to run tests on a part of the ship that few passengers would even know exists.
Hans, why is this little room so important to the passengers?
Comfort. Comfort for the passengers.
This controls comfort.
The ferry is fitted with retractable fins, known as stabilizers, which help limit the rocking motion at sea that can cause seasickness.
So this is the actuator that pushes the stabilizer arms out?
Yes. So, and at the moment in dry dock, we get them out for repairs, cleaning, maintenance, and whatever.
During the tests, engineers will be checking that all the hydraulic systems are functioning correctly and that both stabilizers are perfectly synchronized to work together.
These would only normally be deployed in stormy weathers. The flaps at the back are controlled and move up and down. And they counteract the rolling of the ship from side to side. As this flap goes up, on the other side the flap will go down. Now the really clever thing about these is that they're controlled automatically by the ship through use of a gyroscope system, such that when that gyro moves to one side because of the rock of the ship and the roll of the waves, this thing knows exactly what to do, and it knows how far to turn because of how big those waves are. Clever stuff.
The Pride of Bruges was built in Japan 25 years ago, specifically to carry passengers and cargo 200 miles across the North Sea.
It's high up from there.
Inside, 3 freight decks can carry up to 850 vehicles.
Above the freight decks are 4 more levels to accommodate over 1,000 passengers and crew, complete with 2 restaurants, a nightclub, a casino, and a hotel with 350 cabins.
It's amazing.
It's just this massive, almost like a town with all these.
Well, you wouldn't know you're at sea if it wasn't rocking about all over the show, would you?
Coordinating the maintenance of a machine this large is a massive task. The Newcastle engineering team are due to return the Pride of Bruges to the North Sea in just 20 days' time. Delays would be disruptive and costly. Working to a tight deadline, the team's biggest challenge is to repair thousands of square metres of steel, which is showing its age.
Just try and keep a nice even pattern.
While at sea, the whole steel surface has come under constant attack from marine life.
I mean, if this wasn't being done,
the steel itself will just deteriorate.
Seawater is also corrosive and would have caused much greater harm were it not for these metal bars, currently being replaced by Richie Aitchison.
Richie, what is this piece?
It's anode, sacrificial anode.
Sacrificial anode?
It protects the steel, basically.
Yeah.
Protects the steel.
This is a new one, is it?
This is a new one.
So these are put on the site. How many of them are on the ship?
On the ship, about 50 in total.
The sacrificial anodes are made of zinc, a more reactive metal than steel, which means corrosion attacks them first. As their name suggests, they sacrifice themselves to save the hull. While engineers carry out repairs on the steel exterior of the ship, inside, work is underway to replace 2 steel floors, each the size of a football pitch, in the ferry's car decks.
It's incredibly noisy down here, Neil.
Yes.
Overseeing this complex engineering project is Neil Farquhar.
The reason we're replacing the steel is the wear and tear over the years with the trucks and stuff that goes
back and forth.
The
steel actually wears down?
Oh yeah, it wears down. You've got to remember this 18, 20 tons travelling back and forth on trailers and stuff. If it goes below a certain millimetres, it has to be replaced. To replace all that is a massive job.
To strip out the old decking would take months, so engineers will be fixing a new level of steel above the old one, saving time and money.
The blue machine on the left-hand side is what we call a blast track machine, which shoots shot blast onto the surface to make it absolutely spotless.
Oh, it really does, doesn't it?
So that leaves the welders the clean surface to come along.
It's like filing it down before you...
Exactly.
Over the next 3 weeks, the team not only have to grind the old decking down, but they also have to remove hundreds of manhole covers and fixtures and refit them to the new surface.
How thick a piece are you adding on top?
6 mil.
6 mil more? That should see it right for another 10 years.
Yeah, at least.
Yeah. Extending the life of the ferry is the major goal for this overhaul, and a week into the process, there's still much to do. Over 600 square metres of flooring needs to be relaid as part of the passenger deck's refurbishment. The critical moving components that take the brunt of the forces at sea need to be checked and renovated. And all 4 lifeboats must be removed.
Okay.
These potentially life-saving vessels can carry up to 150 passengers each. They'll be thoroughly examined along with the release mechanism that lowers them into the water.
Part of our service is to make sure that they are working and functioning correctly. Put them into the water, check the release system and do the maintenance.
Safety on the ship is paramount and the main focus for the Newcastle engineering team. They're being helped by key members of the ferry's Dutch crew who have stayed on board to operate the controls and working parts of the vessel.
An old ship, 25 years plus, well maintained, well looked after, good crew on board who love the ship. They do 2 weeks on, 2 weeks off, and obviously treat it as a home.
It's a good team. We've got about 120-ish crew working together with all the people. That's the most important thing. That will help you through the 2 weeks.
The interaction is really great on this ship. Different nationalities, and yeah, that's why I love it.
Sailing for 2 weeks on the ship and we're 2 weeks at home. Enough time to spend at home with your family.
No one knows the Pride of Bruges better than its crew. Today they're working with Colin and the Newcastle team to operate the ship's 2 4-ton anchors.
They need to examine their 329-metre chains, stored in lockers deep in the bow of the vessel for potentially lethal wear.
The anchors are the only brakes that the ship has. Right. It either hits something solid, which is undesirable,
unadvisable, yeah,
and the captain gets embarrassed, or you hang on to what's down there. The ship will not stand still.
What are we looking for in that inspection?
Any defects. That rubs on that.
Yeah.
Naturally, that causes wear. Remember, if they are actually anchored, those things are working all the time.
Yeah.
And there's a maximum wear allowed on them.
To accurately measure the wear on every single link, all 329 metres of chain is released, an operation rarely carried out on this ferry, except in emergencies.
You just see the rust flying off of it as the pressure of each one of the links of those chains goes through the teeth on the wheel. It's just grinding it straight off.
Next, the team must carefully organise the chain along the bottom of the dock, a potentially dangerous task that has crushed dock workers in the past.
They load the chain onto the ship in lengths. After they've loaded one length on, you can see they join it with a red link. After one length, they paint one link either side with white paint. After two lengths, there's two links either side get painted white. After three lengths, three links. So you can see at a glance exactly how much chain you've fed out.
The anchor prevents a ship from drifting away due to the currents or tide.
A common misconception is that it's the anchor itself that acts as the main weight to secure the ship in its position. In fact, it's the weight of the chain that holds the ship in place. The anchor is merely there to keep the chain in the correct place on the seabed.
The final link in the chain is attached to a single pin deep in the bowels of the vessel.
You pull the pin there, which is painted down. There's a backup on everything.
Yeah, of course.
Pull that pin, so that's there so it can't work its way out while nobody's looking.
Yeah.
And then you get your mightiest crewman with him, hit him, knock it out. That pin goes through the bitter end, the last link of the cable.
So the last link of the chain is called the bitter end?
Yes.
And the whole anchor and the whole chain is connected to the ship by the bitter end?
Exactly. Or more importantly, the ship is connected to the anchor by the bitter end.
Releasing the bitter end would be the captain's last resort, casting the ship adrift in the sea.
You build a ship and you hope that will never be used, except for normal anchor chain changes.
Yes.
The anchor and its chain is 25 years old, the same age as the ship. And like many of the ship's 10 million components, as it gets older, it will require an increasing amount of maintenance and repairs. In the end, the Pride of Bruges will simply become too costly to keep running. Then, it will end up at a shipbreaking yard like this one in Belgium, the largest of its kind in Europe. Here, over 50 ships a year are plundered for spare parts and broken up. It's the perfect place to look even more closely at how all ships are built.
There's all manner of activity going on here. Ships being sailed in to get cut up, scrapped, and it all gets loaded up and taken off to be recycled.
Ships usually arrive at the yard in full working order.
Looks like it's just been completely abandoned.
The salvage team, led by Mario Mias, then get to work removing any valuable components left on board.
That's a pretty massive engine.
A working engine could fetch over £50,000.
So how much of this weigh, roughly?
27 tons.
27 tons.
Yeah.
27 tons of engine.
Yeah.
The team must be careful. Removing a heavy engine while the ship is still afloat can weaken its thin, finely balanced hull, snapping it in half.
I mean, that would be disastrous. You've got people on board cutting and suddenly...
People on board, residues of oil into the water, so...
Let alone the value of the ship as well that you could destroy.
It would be a catastrophe. Kan uitlopen, hè?
That's it, it's down.
Job done.
Engine safely out, the remaining hull is now light enough to be hauled up onto dry land, to be cut up and recycled.
Effectively, we're just dragging it from the sea up here onto dry land.
This Mexican dredging vessel used to pump sand and silt off the bottom of South American ports. It has a hull that follows the same principle and dimensions of our ferry, just half the size.
Stood in front of this perfect cross-section of a ship, cut right through it. Just gives you a brilliant picture of the structure and what goes on inside. I mean, better than any engineering drawing could ever give you. And whilst this is obviously built and designed to transport cargo, and our ship, people and cars, the principle's very much the same. The flat bottom hull and the ballast tanks on the side. The other great thing about this cross-section is it allows you to see how thick the hull is, or in fact, actually, how thin it is. That's probably, what, a couple of centimeters at max? And you just imagine how something as thin as this could get ripped to shreds if it came up against something solid like a rock.
It will take another 2 weeks for the salvage team to cut up the rest of this 2,000-ton hull, ready to be recycled. Our ship, the Pride of Bruges, should be at least another 10 years away from this stage of its life cycle.
In Newcastle, the ferry's now halfway through its 3-week overhaul, and so far, the engineering team are on schedule. Throughout the process, one of its 4 diesel engines has been ticking over to provide electrical power to the ship's control systems.
I'm right at the back, or the aft of the ship, the real business end. And down here is where the engines are. The power, this beast of a vessel.
It's the heart of the beast. That's where all the action is. It's alive. And it pumps the energy through the ship, and you can feel it when you're in there. You can't hear anything else, but you feel it.
Even with ear protectors on, when the ship is at sea, it's simply too loud in the engine room for engineers to work safely for long periods. So while the ship is in dry dock, Chief Engineer Hans Pronk and his team have just a few days to check the thousands of valves for any leaks and carry out important systems checks on the engine's complex electronic controls.
So you were able to see here and actually control everything out in the engines, all the pumps, all the generators.
All the things will be displayed on a screen like this. As you see, the controls over here are for pumps, the controls for propellers, the controls for generators, the control for main engines, clutching, declutching,
steering,
everything.
Despite the noise and heat, Hans is never more at home than when he's in an engine room.
When you're out at sea, it's even more noisy than it is now down here.
Yeah. You definitely need a lot of ear protection.
At sea, all 4 engines would be running, constantly driving the ship's 2 propellers, as well as supplying the ship with hot water and enough electricity to power a small town.
I mean, this really gives you an idea of the size of the engines and the pistons. So the diameter of a piston inside the engine is that.
A piston in a regular car engine is closer to the size of a fizzy drink can.
This piston here, that's just been refurbished, has it? Ready to be used again?
Yes, you see, it's not brand new.
Yeah,
Yeah,
you can see.
but it's fit for use.
It's how much would one of these cost new, roughly?
About 7,000 for the top part, because that is being split.
Yeah?
And then you have the lower part, there's another 7,000 roughly.
So around 14,000, 15,000 pounds.
In addition to 30 pistons, costing £182,000, there are tens of thousands of valves, pumps and pipes, all working together to supply the ship with the power it needs.
So what's the power that we've got on here then, Hans?
It's 5,760 kilowatts.
The power output from average cars, what, in kilowatts?
100 kilowatts about.
So that means this is about the same power output as about 58 cars.
Yes.
In total, The ferry's 4 engines generate a power equivalent to over 200 cars. And on a 14-hour crossing of the North Sea, that means the Pride of Bruges will get through over 30 tons of diesel fuel. Back at the shipbreaking yard in Belgium, a fuel tank has been split wide open, revealing what the vessel consumed and how it consumed it.
The fuel they use on ships is one of the cheapest, real heavy fuel oil you can get. I mean, look at it. I mean, this is kind of crude oil once you've taken off gas, petrol, diesel at a refinery. This is kind of what's left. It's like treacle. So on a ship, it has to go through, the fuel goes through 3 different stages before it can actually be injected into the engine and be burnt. The pipework you can see running through, it's kind of like the heating element at the bottom of a kettle. This is used to heat up the fuel. So it goes from this really viscous, thick, sticky stuff into something more liquid that they can start pumping through the fuel system.
So it gets thinned out by being kept warm?
Yeah, it gets thinned out. But it's not ready to be burnt yet. Because actually in this, you've got all sorts of impurities, there's water in there as well. And they've got a really clever system for separating out the stuff that we don't want, so we get a fuel oil that is burnable.
And that system is called a centrifuge, which I'm going to demonstrate with a bicycle and a bottle, full of a mixture of sand, water and oil to represent the ship's fuel and its impurities.
So I'm going to get this wheel spinning here. Much as it would be on the centrifuge on a ship. Now, as that spins, the acceleration forces the heavier objects, or the denser objects, towards the outer edge of our bottle. So let's have a look at what we've been left with.
Wow!
With our little makeshift centrifuge. So you can quite clearly see there, the heavier, denser stuff was thrown right out. And that's the sand. That's the impurities within the fuel on the ship. Then you've got the water. That represents the water in the fuel on the ship. And up top, you've got the least dense liquid in there, and that's the oil. And that would be the fuel oil on the ship, which can then be tapped off and burnt in the engines.
Very good.
At sea, 2,500 litres of this fuel is burnt every hour on the Pride of Bruges, generating over 40,000 horsepower. Most of which is used to turn the ship's 2 colossal propellers, linked to the engines via these 130-metre-long shafts.
This shaft runs right from the transmission right out to the propeller. Yes, absolutely,
The shafts are so long because if the engines and propellers were next to each other, their combined weight of over 200 tons would place too much weight in the stern of the ship, making the ferry unstable.
The propellers work by pushing water in one direction, causing the ship to be moved in the other. The angle and speed of the blades affect the volume of water being moved, and therefore the speed of the ship. At 4.5 metres in diameter and weighing 14 tons each, the 2 propellers on the Bruges can spin at 120 revolutions a minute. They're in the process of being polished by engineer Paul Baker and his team, an essential job they can only do when the ship is in dry dock.
Once they've been polished, then we will crack detect. The areas that you crack detect are in the palm, where the bolts are, and on the tips of the blades. This is purely to identify whether or not there is any surface imperfections or fractures within the blade material.
These surface imperfections can be caused by a phenomenon known as cavitation. When the propeller's spinning, the rapid changes of pressure in the water around the blades can cause cavities or bubbles to form. The constant implosion of these bubbles as the liquid collapses into the void produces a shock wave which can damage the surface metal of the propeller. If left unchecked, cavitation could result in a ship losing a blade.
So this is being inspected at the moment?
It is. We will proceed with the polishing of the blades and the crack detection.
So when you polish it, what's the effect that will have?
Efficiency.
It will improve the efficiency?
It will improve the efficiency of the blade as regards the resistance within the water. So therefore, it will reduce his fuel costs. It's all about reducing fuel costs.
Those costs are further lowered by the ingenious design of the propellers, which enable the captain to control the pitch of the blades, an invention that's best demonstrated by this replica model.
Unlike in cars, where the engine speed determines how fast the car's going, that's not necessarily the case in ships. It's the angle of the blades in the water which is going to determine how fast you're moving. So when the propellers are in this position now, which they're quite flat, it's pretty much like having a dinner plate slapped onto the end of the shaft. So when it's spinning, it's not giving you any forward thrust. Now, when you start to change the pitch, you start to get an increased amount of thrust and propulsion forwards on the ship. If the captain then wants to reverse the ship, what happens is he reverses the angle of these blades completely, such that the water's being propelled in the opposite direction and the ship goes backwards. And that means he doesn't have to slow down the propeller from the forward direction, crank it in, and then speed it back up again. That whole process can be done whilst the shaft's still turning. So this clever design makes the ship that much more maneuverable, with quicker response times, and is more fuel efficient, making it much cheaper to run.
It's now only 10 days before the Pride of Bruges is due to ferry passengers and cargo across the North Sea. And with time running out, engineers must make sure that all the critical components, usually underwater, are in perfect working order. Any failures at sea would mean returning the ship to dry dock, resulting in a huge financial cost and a cancelled service.
A faulty rudder would prevent the crew from being able to steer the ferry into port unaided. So Paul and his team must now check that the rudder's washers and bearings, known as bushers, haven't worn down due to continual movement in the water.
You do get a wear factor on these, and sometimes you have to part the blade and the flap and renew these riding washers.
And what would be the situation where you'd have to actually remove the whole rudder?
If we have a problem with the main trunk housing, if the clearances are excessive, then we have to lower the rudder, remove the rudder, take the post out and renew the bush.
So what's the danger of not spotting something like that where you've got really high clearances?
If you've got a high clearance, you could actually lose your rudder.
At sea?
Yeah, you'd lose the rudder.
So these checks,
they're very important. They're very important.
Housed directly above the 4-ton rudders are the hydraulic actuators that move them. They're controlled electronically by the ship's steering wheel at the bow of the vessel.
I'm fascinated to know how you control a ship like this. So I want to find the nerve centre. I want to find the bridge.
I've arranged to meet the most important man on the ship. It's Captain Harry Cannyworth.
Found the bridge.
Harry, good morning.
Hey.
Good morning, Tom. Welcome.
This is the bridge. I've found it.
This is the bridge, yes.
It's hard to find.
It's hidden behind closed doors.
It seems to be.
For obvious reasons.
The main controls to manoeuvre the ferry in close quarters are located on the bridge's wings that protrude beyond each side of the hull so that the captain can see along either side of the vessel.
We have the bow thrusters here at our disposal.
Now, these are just those little propellers, well, say little, they're about 6 foot, aren't they?
Relatively little, and they can move the bow basically sideways. Yeah.
So, you've got rudder here?
Rudder, bow thrusters, and both engines.
I thought you'd have a wheel. I thought there'd be a wooden wheel.
You want to see the wheel? I think you'll be a little bit disappointed with our wheel. This is it.
This has been modernised, hasn't it?
This is it.
It isn't what I expected.
Well, the big steering wheels are getting smaller. The ships and the rudders that drive them are getting bigger.
As a passenger and cargo ferry, the ship is regularly in and out of port, so manoeuvrability is key. Therefore, the vessel has been equipped with special rudders.
These are Becker rudders. They're a high manoeuvrability rudder. You have a flap, as you can see on the mechanism here, Becker flap.
So what's the advantage of having this on the back of the rudder itself?
It actually increases the manoeuvrability of the vessel.
Water that's been driven through the propeller is diverted by the angle of the rudder, changing the direction of the ship. The addition of the Becker flap to the rudder is an ingenious yet simple way of getting extra manoeuvrability. Because of its position, this smaller flap has a bigger effect on diverting the water flow, making tighter, quicker turns possible.
So what would be happening if you're doing 18 knots, top speed?
Top speed.
Clear day?
Yeah.
And you just went... Woof,
The ship will list considerably.
Okay.
Everything that's not secure will fall down.
Clearly, there's no way to see Harry manoeuvre this ship while it's in dry dock. But fortunately, the Pride of Bruges has a sister ship, the Pride of York. Built in Scotland to exactly the same specifications as its Japanese sister, the York also carries out the daily Hull to Zeebrugge crossing. Between the two ships, they ferry 400,000 holidaymakers and business travellers between Britain and the continent every year.
On behalf of Pina Ferries, would like to welcome you on board the Pride of York. The ship is now secured for sea and we will leave the berth shortly.
As dusk falls, we're offered a rare opportunity to view the most challenging parts of its journey from the bridge.
So, Alistair, why is it such mellow lighting in it?
All craft are illuminated and we have navigation lights. It's an imperative that we see those lights as soon as possible. Any background light on the bridge would spoil our night vision and we wouldn't see those other ships.
It's the same reason as in your car. You
Exactly the same. Exactly the same as that. If you have bright lights in your car, you can't see what's outside the windows.
Captain Alistair McFadden shares the skipper role with his Dutch counterpart, which means tonight he's free to explain how the crew manoeuvres the ferry through a narrow lock on its departure from Hull.
But all the navigation is going on down the other end of the bridge.
It is, yeah. Captain Rowley and the chief officer there are manoeuvring the vessel at the moment.
So this is quite an intricate manoeuvre.
It is.
We're trying to get this enormous ferry
into
this tiny little lock
pretty
here.
small gap, yes. Yeah.
So when we're in there, how much leeway have we got?
You've got about 18 inches either side of the vessel as we move in. It's a very tricky manoeuvre. We use our own machinery, main engines and bow thrusters, and of course the rudders, to get the ship in here. And as you can see, we do things very slowly and nice and gently.
Unbelievable. From up here, I can't believe that's 18 inches. It looks like it's about an inch.
The smallest of errors could result in damage to the hull, where many of the ship's most important components are housed. But the York has been designed to the exact specifications of this particular lock.
Is it not an argument economically to have a smaller ship or a bigger lock that you can be quicker, so you can get more ships through?
The bare fact is that the lock is built, and if they'd built it twice as big, we would have built a ship twice as big.
Now, the ship has to wait until the level of the water inside the lock reaches the same level as the river outside.
The whole idea of this dock basin is to maintain a certain depth of water all the time. So any ships inside always have a guaranteed amount of water under their keel, so they can work cargo throughout their stay in the port.
There we go.
There we go, opening up.
The crew now have to navigate the ferry 200 miles across busy shipping lanes in the North Sea.
This is the route that we'll be taking so we'll be on the starboard side of the channel. We'll come all the way down to the sea reach. Once we get to that point, we'll alter course to a course of 124 degrees, all the way down to Zeebrugge.
Today, ships are equipped with global positioning systems that use satellites to fix the ship's location to within meters, and an automatic identification system that then broadcasts the information to nearby vessels. Superimposing that information onto the English Channel reveals how ships have to stick to lanes, like traffic on a motorway. But despite all the latest technology, a captain must still be able to fall back on the charts.
Like any prudent mariner, you don't rely on electronics. So we could take a bearing and distance from a point of land using the parallel rules here.
Yeah, recognise those.
Yeah, very simple tool, very effective. And it's used by lining up on the compass rose here, and then you line up to whichever bearing required, and then you can just simply move them across the chart to transfer a position line.
Okay.
Very simple, very practical, and sadly, soon to disappear.
Soon to disappear? How come?
Well, modern ships are now moving towards electronic chart displays, and that will be their main navigational source. So all of these paper charts will disappear.
Alistair's worked on ferries like the Pride of York for 38 years, and I'm keen to know if he has an emotional bond with these ships.
I think you do always develop a bond with the vessels you work on for any length of time. It's not the ship is just a vessel. It's the people on it that really make a ship. And you can have the best ship in the world with a rubbish crew, and every day drags, it's horrendous. And you can have a really older ship with lots of challenges, but with the right crew, it's a pleasure to come to work. Fantastic.
What's the most challenging thing for you when you're captaining a ship?
Weather.
The weather?
Weather.
Is that something you relish as a challenge?
I don't think I would ever say I relish the challenge of the weather, because we are mere mortals, and I think, you know, from my experience, the people that get caught out are the guys that relish the challenge.
Right.
The ferry has all the latest navigation technology to help, while sensors located throughout the vessel give early warning signs of any engineering problems and hazards, including flooding. But it still needs the skills of its crew to sail this ship safely in all weathers across 200 miles of North Sea, with up to 1,000 people on board.
This is such a gorgeous way to end a journey.
It's an incredibly civilised way to get across to the continent, isn't it?
Yeah, it really is. Very civilised.
Our arrival in the Belgian port of Zeebrugge gives us a chance to return to the ship's salvage yard nearby to see what happens to a ship's carcass once it's been torn apart.
This is what ends up happening to ships at this scrapyard. Without any respect for the work they've done. They're just getting munched up by this shearer and thrown up on the scrap heap.
And this is what the salvage team are after. Steel. Mountains and mountains of steel.
750,000 tonnes of steel is salvaged at this recycling yard every year, ready to be shipped up the river to the ArcelorMittal steel plant, where the next stage in its life cycle begins. Here, containers the size of 3-storey buildings carry molten metal through the giant production line.
It's just so impressive, the size of the equipment and the temperatures involved.
5 million tonnes of steel is produced here every year, a quarter of which is made from scrap.
Here we have just 3 days worth, and it's all waiting to be recycled and turned into cars, bridges and fridges.
The scrap steel is loaded into enormous containers the size of a bus and transported to the converter, a vessel capable of producing 295 tonnes of steel at a time.
I mean, that is a hellish noise to match kind of hellish vision in a way, isn't it?
Hot metal, produced by melting iron ore in a blast furnace, is then poured on top of the scrap metal. The temperature inside the converter is now a scorching 1,650 degrees Celsius.
Wow. So as they pour the hot metal in now, it's just an incredible firework display. 220 tonnes of molten iron being poured over 80 tonnes of scrap steel. I mean, they should sell tickets for this. Unbelievable.
Steel is essentially iron, with many of its impurities removed. Specifically the carbon, which is weak and brittle. To reduce the carbon, the next stage is to add pure oxygen into the mix.
Wow. Extremely bright flame there suggests that's the oxygen lamps being put inside. They inject oxygen for about 15 minutes, which helps take the carbon that's in the metal and turn it into carbon monoxide and carbon dioxide. Once that's extracted, you're left with a more pure steel that we're looking for.
Once the converter has been emptied, The purified steel must go through a number of processes to cool it and mould it into usable sheets.
This is where they cool the ingots of steel down using water, presumably from the local river or canal. In Sheffield, they use the local rivers, and that causes the temperature in the river to rise by just enough to allow fig trees to grow on the riverbanks of South Yorkshire. Wow, that is so impressive. And this is a finished item, a huge roll of steel. What I must describe to you is how hot that thing is. You can feel it from here, it's searingly hot. Some of that once made up the ship that we saw floating on the ocean. Now it's been turned into this. Its next thing is going to be turned into your next car or washing machine.
It could even be used to build a ship.
In Newcastle, there are now just 2 days until the Pride of Bruges is due to head back into service.
Work's begun to cover the part of the ship's hull usually underwater in a special paint designed to prevent the build-up of marine life, therefore improving the ship's fuel efficiency, as paint quality inspector Tim Emerson explains.
Once that growth attaches itself to the ship, it slows the ship down. It has a dragging effect on it, yeah? Which obviously means that they've got to use more energy to drive the propellers to make the ship travel at the same speed, which obviously is impacting on the fuel costs.
I find it hard to believe that a few barnacles is going to cause a problem of fuel efficiency.
Yeah, it can cause a huge problem. The amount of fuel used to drive these vessels is huge. Typically, you're looking at around 90 tons of fuel a day, typically, if there was no anti-fouling on there. Once you put the anti-fouling on, you can reduce that down to between 40, 50 tons a day. If it was going in your pocket every day. Me too, I would like it as well, yeah? You know, we wouldn't have to work again.
The anti-fouling paint is a technological marvel in its own right. It's been cleverly designed to react to movement of the ship through the water by continually shedding microscopic particles of itself. This means that marine life is unable to get a grip on the hull.
Every last square metre of the ship, above and below the waterline, has to be repainted. And with the Bruges already scheduled to carry passengers on the same day the overhaul is due to finish, for the next 48 hours, they have to work around the clock to get the work done.
It's the final day of the overhaul, and the Pride of Bruges is almost ready to bid farewell to Newcastle.
It's been well maintained, and I think it's a dedication of the ship staff and all departments that keep it in the condition it's in now.
Over 4 tons of paint now cover and protect the ship's exterior.
After 25 years, it's still in a very good nick, so this is a major achievement. And we'd like to keep her like this and try to maintain her as such.
The passenger levels have been refurbished.
Yeah, I'm proud that we have accomplished what we did. It looks a lot better now.
Yeah, everything what should be working is working, which is very nice to know.
Propellers have been polished and tested, and the rudders have been serviced, ready for inspection.
It's looking good, isn't it? It's looking spick and span.
It looks very good, yeah.
Now the team have to get the ship back in the water. Engineers open the sluice gates to flood the dock. Refloating the ship is a risky operation, especially in the critical moments when the ship lifts off the blocks, as docking master Alan Webster explains.
It's a term that we call the point of criticality.
Right.
That's where the ship's at its most dangerous, from being on the blocks to becoming free-floating.
How do you account for the fact that there's no passengers on it, there's no cargo on it? So it's a dangerously light point.
Yeah, that's why we have to reballast before she lifts off the blocks.
Because if we didn't,
chances are the ship will capsize.
Really?
Yeah.
OK, so to prevent that...
You've got to put the ballast back in.
Put the ballast back.
Yeah.
Late in the evening, the Pride of Bruges slowly lifts off its blocks and floats for the first time in 3 weeks. Once the level of the water inside the dock is at the same level as outside, Alan gives the signal to drop the gate.
Yeah, just checking, are the gates on the bottom, can the trucks go in?
What draft is he, Russell?
His team have a narrow window of just over an hour to manoeuvre the ship into the river before the tide goes down and it's left grounded. Tugboats slowly tow the ferry from the dock and Alan's work is done.
Not so bad, no, it's all right, yeah. Timed it nicely.
Thanks to the work of the Newcastle engineering team, the Pride of Bruges should now be in service for another 10 years.